Stream Deck froze. Like, I was using it just fine, and then I go to hit the button to toggle the lights on, and it just didn't do anything. So, how's everybody doing? We're not doing the book today. I'm too addicted to reverse engineering. I want to figure out how this thing's working. We're getting to kind of the more interesting parts. There's some stuff left to do for the little bits of reverse engineering that I want to do. I put a picture of it in the stream project section, but there's some stuff going on under the chips that I want to make sure that I suss out before we start to put this thing into, I guess, Fusion 360. We can load it up into Fusion 360. Let me make sure that's all updated and stuff here real quick. Let's do Fusion. I'm going to need to make a bunch of parts for Fusion 362. We can either find them or, since they're all just SOICs, I can probably just make them. But I'd like to give them proper symbols, too. That's going to get a little complicated. And hopefully that doesn't bog us down for the entire stream. I really hope that isn't the case. It will probably end up taking up a bunch of time, but building parts I've kind of gotten more used to. Yeah, I'm not gonna model it like as in make exactly the same thing. If I do end up making one of these for myself, if I really want to pull through all the way to that, you know, end of fruition on that thing, I'll probably make it in my own style and try to make it a little smaller, maybe. I don't know. I'm not sure if that's where this is gonna go, but I would like to get this thing in CAD. It'll be a lot neater in CAD than if it's in MS Paint. Although I could do it in MS Paint, that would be perfectly fine, and we'd be a little bit more nimble in terms of like making certain parts. But I mean, part of what I want to do is show the process, so. Why is it always full screen? We're gonna update Fusion so that doesn't bog us down. Again, this is Ajinata Deep. I'm going to try to get this little M303 reverse engineered to our liking. Huh? There we go. Okay. I was like, I thought you froze, bro. We can move back with the microscope, I think, a little bit. Let's get that out of the way. Diet Dr. Pepper. So we're going to have to do a little bit of probing with the multimeter just to figure out who's connected where. Because some stuff is going on underneath these chips that I don't know. You know, what's going on under there? I could desolder them and just look under them, but I don't really think that's going to be strictly necessary. I don't want to risk pulling pads. And I guess I'm going to work on that a little bit during the intro. Get the multimeter out, just so we're not wasting time. Time is our biggest asset here today, and I don't have a ton of it. And I want to get significant progress done on this thing, because I told Dave I'd fix it, but I don't know if he knew how far I'd go, what I was capable of, who he hired to do this particular job. He got me out of retirement. I need you to reverse engineer something. I haven't been in the game for years. I ain't going back. I promised I never would. For her. Why is my windowed mode? Fusion 360, they did not bother to program any sort of window size retention. Windows 101 kind of shit. So every single time I boot it up, it's like, let me go to this monitor. No, wait, let me go to the other monitor. Wait, let me go to this monitor. And then it's like, hey, I'll just resize myself. And I'm like, no, I don't want you to do that. We've got a very strict size requirement here with the streaming computer so that everything is displayed properly. And every single time I touch this program, I have to, what is going on here? I thought you already downloaded it. This thing lies and lies and lies. All right, we'll take a look under some of these chips and figure out what the connections are. Now, with this drawing, I've got some problems with it because I accidentally put some stuff on this base layer instead of actually on the appropriate. There's just some layer issues. I think I'm gonna have to pack it down into these layers only. Like this should go all the way in front, I guess. And these three should be attached to one another. Either way, you know, it's useful enough for what it is. Let's find one of these bad boys. Yeah, see here I've got vias coming in underneath it, and I don't know where they're connecting. And these are all different op-amp circuits. So it's like, all right, I can pick up on that one. Not quite over there. I can pick up on it. Wow, this thing travels. Under the, but then, okay. Yeah, we're gonna have to hunt down some of these when we get started, which I might do in just a minute here, because again, like I said, I'm addicted to reverse engineering. How are we doing over here? Yeah, there's people trickling in. I wanted to do the book today, another circuit in the 74 rather, circuits book, but I've just been making progress on reverse engineering this board, and I'm really curious to see how it goes together. So I want to work on this thing. So we need to get under these chips and figure out what's going on. I'm just going to start early. I don't have much else to talk about. Let's get going on this thing. I need to figure out what's going on under the chips. I've made a couple different mistakes on the board itself, like under the board. I've made a bunch of different like little mistakes. And well, no, sorry, little mistakes as in like the layers aren't what they should be. I wanted to have a top layer, a bottom layer, and then the pictures of the circuit board below, but I accidentally drew on the pictures of the circuit board and stuff. So I was not a good engineer in that sense. I messed up. But that doesn't mean that I tanked anything. It's still a totally useful document. We just have to look at it with all the stuff at all times, which is fine. And then in some cases, I'll probably have a harder time if I really have to identify like the values of parts. I'll have a bit of a harder time doing it just from the image. But we need to figure out what these things are too. I believe they're probably diodes. That's my suspicion, is that these are diodes and this is a diode ladder filter. But we don't know that. We don't quite know that. You know, we know where the traces are underneath the board and above the board and stuff, but we don't know exactly what the intent of the different circuits are. Like, where do those go? So we need to get through areas like this. Even though it's still a very sloppy document, it displays... Here, let's get the desk view out of here. That'll be this one. Oop. Go. We can just do this. We need to get these areas where stuff is covered over and figure out what's going on, because I know where traces are coming in underneath, but I can't see under the chip. So, and knowing what this thing connects to will help us narrow down what it is, because it's a specialized chip. They went to the trouble of censoring this from us. They didn't censor any of the op amps. They censored the LM13700, whatever that is, the transconductance amplifier. But they didn't censor any of these other things. Now, there's a couple ways that I can do this. Mostly ohms are what's going to rule here. Ohms are going to tell us everything about what's connected to what. But there's a couple little techniques that I can use in order to utilize the multimeter properly. Now, one of them is to trace out where I think these are going and see if there's low ohms between the two endpoints where the solder mask is uncovered. Push comes to shove, I can actually poke in to the trace with these very sharp leads. So, supplement. Yes, yeah. So yeah, things happen under ICs and we don't know what they are. There's shady things going on. Now I have a hot air station. I could pull this chip, take a picture, be done with it. But you can see there are some traces that look like they're not really going to anything. So if, wait, why didn't that one show up in chat up there? What the heck? Something weird's going on with the memory of this computer. I think it's just been powered on either too long, or there was like a Windows update and now everything doesn't like quite work right. Stream Deck was frozen. Test. Bonk. Are you freaking kidding me? Why is everything like not working? What's going on? Capital test. Are you kidding me? So my social stream blade is not updating. and the chat up there is not updating. Test. That's not working either. Oh, that one went into the social stream blade. What is going on? Look at that. That one went in. It didn't go up there. Maybe if I refresh, where is that one? Chat, Streamlabs. Like Streamlabs never freezes. Properties. Whoa, what is taking this thing so long? Is it that this is like tanking everybody? That might be it. It's whatever limited bandwidth apparently I have for Twitch. It's being tanked by my bitrate 6,000. So what the hell's going on here, Twitch? You wanna maybe just like let me do my thing, or are we gonna get in the way today? Is it gonna be one of those days? It's like a real cloudy day and the atmospheric pressure's up, so like my skeleton hurts. Everything is like real slow to load. Look at this. All right, who's doing what? Alt Control Delete time. Task Manager. I've got a billion things running on this computer, but usually it's pretty good to take like multiple loads. Gotta watch what I say. System interrupts, 100% CPU. %100% CPU usage right now. Anti-malware. Chrome. Chrome takes up... Chrome's a goldfish. Why is anti-malware... Why is Defender anti... Is it on? Wait a minute. All that stuff should be off. Did they turn it on in the update? They probably turned it on after the update, didn't they? And that's what's slowing this computer to a crawl. No, it's not on. Not on, not on, not on. Current threats, no current threats. Well, why are you taking up my whole CPU? Real-time protection is turned on. What is this? Oh my God. Off, you frickin' ghoul. Yes, allowed. Jeez. Okay, so it turned on real-time protection and tanked this machine, which is a working machine that I don't install weird... Well, I do kind of install weird stuff on it. If it gets a virus, it'll be funny. So... What is streamer.exe? Wait a minute. Is that a virus? How did anti-malware turn back on real-time protection? Behind my back, Microsoft. Isolated browsing and exploit protection. No, 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 no. Firewall's off. Okay. Yeah, if we slow your PC down to a crawl, you probably won't get any viruses. There's the warning thing. I gotta check on my other machine now to see if any of that crap is going on. Okay, so sorry about the viewers that left as soon as I started to get my computer to work again. Jeez. 98%. Hurry up. All right, now let's restart that. So what happened is the anti-malware stuff was enabled when the computer updated, and that made the computer use a lot of resources. And so Chrome backed off on the resources. And when Chrome backs off on the resources, it will like shutter some of the pages that I have open in Chrome. And so Social Stream Blade relies on those pages to be running. Wow, all of my icons came in separately there. That was weird. And so if it like says, oh, you're not using this page, but this page is up there so that Social Stream Ninja can see all the chats and put it up into the boxes on my stream. So Chrome needs those resources. It needs to have those resources so that it doesn't shut pages down. And this advent of Windows changing your settings for you is one of the most frustrating things ever in my... Like, okay, there's two things. And this is like a modern attitude that programmers have where they say, well, everyone should have the latest version of our program. And so they force it on you. And this is what happened with my insulin pump. Everything was working great, right? No other systems around the insulin pump were updating or breaking or doing anything weird like that. While the latest version exists and it works on modern hardware, that's wonderful. But with my phone is a Pixel 6. It's not the latest hardware. And so those exploit fixes are all well and good, and I have full intentions on updating, but forcing the update on people and locking out features could cause them to die. You could literally fucking die if at 4/29, the date 4/29 at 12 at night, you are end-of-lifing a feature on the old version. That is extremely dangerous because it's health software. And so I go to bed, I'm hyperglycemic, I get no corrective insulin for several hours because I'm asleep. I can go DKA, I can go to the hospital, I can die. So it's like, but these programmers, these worm-brained programmers go, we need to update this function, they need this. They don't know what they want. And so in the same vein, hey, look at that. Suddenly, yeah, a literal end of life. And yet that chat did not go into the frickin' social stream blade. Chrome is currently getting its tendrils into all of the pages again, and hopefully updating all of my chats so that they actually work. But like the same thing happened, but on a lesser scale with the Windows Update. What the Windows Update did was they said, well, everybody will want real-time protection on. We have to have them protected. And so in doing so, this computer with a ton of things running at once started to divvy out all of its resources to this new thing that wanted to scan every single piece of data coming into the computer, which is typically fine. Like on a parental computer and all that stuff, like I would definitely enable it. But this is a work computer that doesn't see a lot of strife. It just does its thing. And it needs to be nimble because it's an older computer and I'm a streamer, so it needs to work. It's got a decent processor and everything on it, but as it started to divvy out those resources, because it has plenty, Chrome said, oh, you need some resources, we'll back off. And then it shutters the pages. It basically freezes them in place until you click on them again. And in doing so, it broke all of my on-chat programs. Let's get YouTube in here and see if anybody was actually talking in YouTube. Okay, so there's YouTube. Madam U said, hey, what's up, Madam U? How's it going? I forgot to pop out the page because I'm too distracted. I need to go to, oh bother YouTube, oh bother VOD rather. Chat, Twitch, oh bother, oh, at O underscore bother, V, capital V, capital O, capital D. Twitch.tv/oh bother is the alternative place. There's my fat ass. All right, let's pop this mofo out. Pop that chat out. Okay, there. So now people can talk in YouTube, and they should be seen on screen now, hopefully in real time, although everything is breaking down. Everything is starting to break down on this computer. On my computer. I keep reading, you're going to model the whole board, huh? Here at Auto Pancreas Systems, we take end of life. Yeah, exactly. I decided to end of life the version and some of the users. That's what it is. And why can't they see that? Well, because they're too worm-brained programmery kind of people. You know, these people that get kind of insular, they're sort of in their own world. This is why consultants exist, by the way. Are you catting? Yeah, we're gonna do Fusion 360 today. I have decided, and that actually showed up on screen. I just wonder if YouTube comments will show up. We're doing Fusion 360. Everything is updating right now. We're going to try to go from, and this is not something that I've done. I've done this with other CAD software, but we're going to try to go from, what is it called? GIMP. I'm going to model my GIMP in Fusion 360. Why can't they think of a better name for these programs? All right, new version should restart. Now watch, it's going to restart, but it's going to start up in a different monitor, and the window is no longer going to have that size. Because apparently the Fusion 360 programmers can't handle Windows UI 101. I don't ask for much. I ask for quite a bit, but I don't ask for much. Most of the experience with this CAD software is smooth when you know what you're going to do. Fusion Eagle is a bit of a struggle, especially when it comes to making a parts library. Your parts library can bite you very, very easily. It is a nightmare sometimes. In this case, we're using all SOIC and surface mount style parts. I'm not going to put the exact parts in. I'm going to put good enough parts in, I think, because what this is supposed to be is a schematic over anything else. The only problem is that transconductance amplifier is kind of a weird thing to draw, so I don't know how that's going to work. Oh, and look, and now this one isn't updating still. Let's go to chat again. What other CAD software have you tried? There was a weird CAD program that I used from a guy in Florida made it. This one guy in Florida makes this CAD program that does circuits and allows you to import an image. And apparently that became the de facto standard for like a pretty big effort of the FBI Technical Center. Wouldn't it be cool to be that guy who made that CAD software, and then you just have to kind of support it for this one house that buys all your software? That would be so cool. You're just like, yeah, I'm gonna do like a little software update and then make like $1 million. Craziness. But yeah, it was a cool little CAD program. It was made by people who spoke English was one thing, and so all the shortcuts were like as if you were typing a message to somebody. You'd be like PL place line, and then you would or place trace or something like that. It's been like 5 years since I've used that program. I opened up FreeCAD once, and then from then out it was AutoCAD and Inventor that I've been using for stuff. I am now fully on Fusion 360 because they absorbed Eagle. I used to use Eagle up until version 7. I think I had a professional license for version 7, and then after that they were bought by AutoCAD, and then AutoCAD made the free Fusion Eagle. I have an educational license because I'm educationaling you. If you can sort of get a student license or maybe bend a couple questions, they're pretty lackadaisical with this stuff. If you start making money off of their software, though, you should probably pay them. That's sort of what the license is. I'm going to try to reboot chat up there so it actually works. What would you suggest for a total beginner who wants to get into robotics design? I have absolutely no idea. I cut my teeth on AutoCAD. In college, we had courses on AutoCAD, and that was so long ago that we were doing command line functions for it. I like Fusion 360. I haven't done enough of the motion modeling to really be confident in suggesting it. I don't know where you would start out with robotics. We do things with robotics here, but it is only as a necessity. It's not a venture into generally getting into robotics. It's always a means to an end with this. And that's a lot of the engineering we do here. We're a little bit more nimble than that. We sort of go from category to category to discipline, picking up what we can along the way and being bad at everything. That's how you do. Jack of all trades, jacking off none. What? Huh? That's how that phrase goes, right? Where is my chat? Chat is under... That's not the right one. Let's see. We are looking for... What is that one still even doing in there? That's the chat background. I can delete that one. Oop. Yes, I'm sure I want to delete. Thank you for asking, OBS. This one is... That's just the shading on it. And then this one, I go to properties and I go down to the bottom and I refresh the cache. There we go. Okay. I think the other ones are working. We'll just keep our eye out for the other ones. Let's try this. Yeah, there are my testes right on screen. Perfect. Okay, so we are doing a schematic, and we are doing it from my GIMP, who's very generous. And we are going to try to at least jot down our notes. This is a synthesizer. This is a synthesizer. What's up, Metric Fox? Is YouTube working? If somebody's in YouTube, if you could leave a comment, that would be amazing. You only use 20% of the knowledge to make 80% of the things. The thing about 2080 and engineering is that you train and train and train in a lot of the background stuff so that you know the simple thing. If you go, well, I just paid you to solder a wire down, and it's like, well, yeah, but you also paid for my entire education that told me what wire to solder down, what solder to use, how to hold the tweezers, how to do this, blah, 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 not hurt myself and do all this. So you're not just paying for the job, you're paying for somebody skilled enough to do the job simply. So don't undersell yourself on this stuff. This is actually quite complicated. It might be fun. There's nothing against it being fun. There's nothing wrong with it being fun. It's a bit of work, but it is a puzzle. And if you see it as a puzzle, you'll never work in a day in your, that's the dumbest phrase in the world. You will work, but it's fun work. You can get a little bit of satisfaction out of a job well done. Of course, here I get, the satisfaction I get is probably going to be a cease and desist from Acid Labs. But we'll find the underlying design of a bunch of these areas once we kind of get down to the brass tacks of this thing. We're going to get down to the design of these things, and we can then Google what it does, and we can figure out what's going on. So this will be kind of fun. I like doing this stuff, which is why we're doing this instead of the big book of circuits. And you guys, like, somebody at the end of last stream was like, what about burn the subs? And it's like, go fuck yourself. Like, man, I'm on a roll here, and I'm having a lot of fun doing this, and this is actually a fairly complicated thing. Anyway, we're gonna have to lighten up the red, because I accidentally, down here, the whole thing, I accidentally put stuff on, where is that? The wrong layer. Oh, it's right here, yeah, here. So if I unview the circuit board, you can see stuff disappears. Which is my fault. I screwed that up. So in order to make the traces a little bit more visible, because I used the pencil, very specifically used the pencil, what I can do is I can select by color. And I can choose the pencil color. Why is it highlighting a bunch of... Oh. I'm on the wrong layer, that's why. Select that by color. There we go. So now we've got all of the stuff that I drew with a pencil. Let's just lighten it up a little bit so that we can actually see what we're doing. White would be a little jarring. We'll just do light red. And then I guess the best way I have to do this, other than hitting delete, is to just use a very big pencil indeed. Oh, this is the brush. Wait. Oh, no, that's a pencil tool still. Why are you... Oh, my God. Why did it do that? Did we not select? I thought we did. Oh, and then we might actually not be selecting the stuff on this layer either. Yeah, see, it's not selecting some of the stuff. We'll have to do it to both layers. But why is it selecting everything but? It shouldn't be on the surround. It should be... Well, I can just invert it. Now we're selecting the stuff. I can just lighten it up. This will also let me see what I haven't, what I don't have on the right layer. But I can select by color on the base layer, and then I'll be able to fill it in, and then we can turn off the background. What we need to do right now is we need to go behind stuff and see what's going on behind things. So, all right, there's that. Select none, nothing. And then I'm going to go to this layer, and I'm going to select by color. And choose that one. And then do a big pencil, change my layer up one, so that we're on the right one, and then fill it in using that. So that area is now brought to the front. This area is where I just made a little bit of a mistake. Sounds like something somebody making a nuclear bomb would say. I don't know what you heard or who you've been talking to, but that's not what we're doing here. Jeez. Oh yeah, I still found it up from when we were looking for a screw. I don't know, that's kind of a weird thing. I'm just going to leave it alone. Select none. I had, at some point, we had one of those little things where you have people come into your office and give you like a presentation on stuff they were doing, and it was on nuclear bombs. So I doubt they're giving me super insider knowledge about how nuclear bombs operate, but they did have some cool stuff that they were talking about. Oh, that was kind of neat. It was just one of those like lunch presentations that you would get, and I'm like, oh, these guys know about nukes, huh? They were like, we thought it would be interesting since you guys work with IEDs, we might as well teach you how to make a nuclear bomb. What? Wait a minute, huh? Okay, let's see. So we got top layer and bottom layer, right? So our top layer is all in red, the bottom layer is all in blue. Why they're separate is beyond my understanding. They don't really need to be separate. It just kind of helps us to be able to turn stuff off. So if I really want to see what our schematic looks like, let's put a new layer in here and just do a white page for that. So I'll put that behind our stuff, and then I'm just going to fill it in with something that lets us see what's going on. Actually, to be kind to you guys, maybe we'll not make it a white page. We'll make it a little bit darker than that. I'll do dark gray, and hopefully the blues and the reds won't super pop out of it. A much larger brush than that. Oh my God, it's like fill in the pixels. Allow me to take all the memory in the computer and use it for that. Okay, there. So this is what we jotted down from the board. These are all of our circuits laid out. We got to go back down to like a 3 brush. That'll be fine. And then go to the previous color that we had, just in case we need to jot anything down. Okay, cool. So yeah, okay, the red pops out from that a little bit. Ugh. It's a little bit poppily. It's popping out. But yeah, so now we have all of our elements here, and we can start to figure out what does what. Now there is still one thing that oh, wow. How did you get by me? Dead. There's some areas that I need to like clean up. Some things that need to basically, we can't look under the parts, and I don't want to desolder them because it might pull pads. I don't want to damage this thing any more than I have to. So we will take a look at what's under some of this stuff in order to figure out what the circuit layout is. What is going on there? Oh, that's a trace that should have been blue. Wait a minute. Did all of my traces get... Okay, we're going to Control Z a bunch here. Oh, some of the traces down in this area were actually supposed to be blue. What layer are they on? They're on the red layer. Okay. Well, I don't know. I don't want to redo this again, so there was a little... I probably should have colored some of this stuff in blue. No, I don't regret using... I don't regret anything that I've done previous to this. I have no issues. What is going on here? That's a ground that I didn't get. So flip color, go to layer 1, and reduce the size of my pen. This is all going exactly to cake. There's no issues with anything that's going on here. What's going on up here? That's those two. So this one's probably connected. But this one is just floating. So what is that one? That one is right by that resistor. Let's take a look at it. Actually, we can look at it on the microscope. There it is. Bonk. All right, let's see. So, oh, that's actually kind of harder to see with a... I actually can't see that. Okay, so let's just go to the main view. Boop, much easier. And so we're looking at a pointing tool. Where's my... There it is. Where are we? So we are somewhere in this area. There's 2 transistors there. Oh yeah, the SOT235 is right there. We want to go a little bit north of that. And let's see. We are somewhere in the midst of this stuff, this kind of sloppy stuff going on here. And we have this trace right here that's kind of a little bit less viewable on our angle of microscope. So where do you go? Fatanon, what you doing, bro? How's it going? Hey, thank you for subbing with a... Do mine eyes deceive me? That is a tier 3 for 52 months. One of like, I think 2 tier 3 subs on this channel, and you don't have to do that, but you do. Thank you. I'm floored by your generosity. That's amazing. We're doing some reverse engineering. We've been doing this for a little bit. People have been giving me bullshit about not working on burn the subs. Well, it's burn out the subs, more like. I have sunk my teeth into Dave's 808. This is Dave of Julian and Dave, who are friends. Come over here. They fool around with their synthesizer. I can't stop them. I've tried squirting them with water. They still do it. They just come over here and fool around with synthesizers all the time. And there's nothing I can do. With the school year wrapping up, Dave is going to be back into doing synthesizer stuff more. So I want to get a good reverse engineer going. Acid Labs did us dirty. AcidLabs.de makes this module. It's pretty awesome. We found out yesterday that it's worth $600 and that there's a possibility we could get one for $10. on an industrial supplier website. I think they Googled a part number that they had and found a picture of the M303 and put it up on their website for sale for $10. I think that was maybe a bot that went through a bunch of stuff and messed up. But the thing is, Acid Lab did us dirty. They scratched off the values on some of their chips. In the past, we've taken images of these chips and used a little bit of Photoshop fuckery in order to figure out what the numbers were behind it. This one's pretty blasted. We also did a little bit of like burping. We did some very minor reverse engineering of the circuit surrounding the chip. You know, like I just want to eat a salad before actually streaming, and so I eat a salad, and then I start talking to you guys, and my esophagus is like, hold on, and I'm like, I just die. I can't get through a sentence suddenly because my body has decided that it would churn things around. It's like, could you not for like, just let me get through this sentence, then you can make me like burp or whatever, puke on stream. Actually, that get into the fetishes. Anyway, the point is, we've got this chip here and we don't know what it is. We've got a couple of these and we've got a whole design that we don't know what it is, and we have to fix it. This design is prone to being plugged in wrong because Acid Labs is very unforgiving about their power input design. They don't even put diodes that would have saved us on here. So if you plug it in a little bit wrong, you can blow up your module. And so that's what Dave did. Now, Dave is going to probably want his nice acidic M303 back. In the process of figuring out what I should be looking at, I don't know a lot about analog electronics, and I kind of want to learn about analog electronics, much to the chagrin of the people who keep annoying me by reminding me to finish other projects. But the point is, you know, this thing has been here for a little while. I would like to get this done. What I did, no, I don't want to get into RF. I've already been into RF. I've done RF before. Oh my God, no. No. I know my way around RF, which is not what a lot of engineers can say. I've had tutelage from some very experienced old RF engineers, and I have no purpose for RF in the projects that I'm doing at the moment. Everything has built-in wireless, and I can just program it very easily. I don't need to start hanging antennas as much as I hang brain. This right here is an M303. It is a modular synthesizer module that's meant to replicate the legendary MC303. But the MC303 has a sampler in it. So there's some special stuff, some special sauce that Acid Labs did in order to make this thing operate as a standalone synthesizer. They have stuff in there that's making the waveforms. So we need to suss that out and figure out what blow up. Why you blow up? What blow up in you? We tried replacing like one of the chips that we were pretty sure the value of. We got a part number for it, and we overlaid the part number, and it looked like exactly the right thing. So we put that new chip in, and it's still heating up. And I don't know what else is going on in this board. So I need a schematic. Acid Labs does not have a schematic. I'm making a schematic. I'll probably put it on GitHub when I'm done. But what I want to do right now is start to get this thing into CAD software, because then we can put down what there is and start rearranging things to clean it up. That's not going to happen for a little while, because first, now that I've gotten the top layer and the bottom layer into image manipulation, I've been able to trace out all of the traces, and now I have a document that is recording what all the connections are, except we can't look under the chips. I could heat them up, I could pull them off, I could put them back. I don't want to do that, because that tends to rip pads if you're not careful, and if we're doing it in bulk, it's probably gonna end up damaging the board. So I don't want to do any more board damaging. Instead, what I would like to do is just a little bit of ohming. TB303, not the MC. The MC Groovebox is a Rompler-based drum machine. Oh, is it? The TB is an analog-based bass synthesizer. That would be what it is, and maybe that's my confusion. Again, I don't know a lot about this stuff, so I didn't know that the TB303 was what we were actually looking at, which probably means we can find a schematic for it. Let's take a look real quick. And then that'll help influence the circuit that we're looking at. Because specifically, Acid Labs did a lot in order to replicate the old school sound of the TB303. I'm going to try to get that right from now on. They did a lot of effort. They put a lot of effort into replicating the sound of the TB303 with more modern electronics, because things have been like discontinued and stuff like that. Chips don't live forever. Some of them get discontinued. So let's take a look real quick. Let's take a look real quick at the TB303 schematic. Roland is nice. They output schematics for all of their stuff. TB303 Nuclear bomb schematic. Wait a minute. No. That was the wrong TB303 schematic. Sorry about that. I don't know what came over me. TB303 schematics. Your connection is not private. We don't have a lot of privacy these days. Let's just keep going. No! Okay. You killed them! The schematics. Music machines. That seems reputable enough. So if we could get... God damn it. If we could get a TB303 schematic. There was one where they highlighted stuff. That's a little close in. We need, like, the whole thing. I mean, we could also look up the service manual. I think the service manual probably has... Service manual. Okay, so this is much better, clear. Because now we have a PDF with the schematic, and the PDFs are nice because you can zoom way in on them. This is looking a little bit more like what we're looking for. That's right, we had this open the first time we were looking this up. MC1401 BCP, quad 2-input NOR. We have a couple op amps on a weird thingy. The HG14584B, we have a slightly different Schmidt trigger in ours. I don't know what the hell that thing is. There's a flip-flop, a little flippy-floopy doodle. Whatever the hell that thing is. So these are the things that were updated, because some of these are no longer really available. This is the one that we looked at last time, the quad analog switch multiplexer. Red means recording? Yeah, I've never heard the term rompler before. Rompler. It sounds like a robot that you'd make that, like, bumbles around. Very important that we know what screws this thing has. Yeah, so I remember this from the last time we looked at it, and this is like a breakdown of all the chips that they used, which is pretty cool. Hex buffers, Schmidt triggers, NOR gates, op amps. We found some similar stuff, but we have some specialty stuff. Oh, ROM sampler. I don't think so. The modular synthesizer module, the Acid Labs DE module, it's not doing anything with ROM. I don't think it's doing any kind of sampling ROM stuff like the 303 did. Actually the 303 that I looked up is a lie. It samples an 808 drums. It samples the 808 drums and just has a DAC in it. I didn't know that. I was like, I thought I was making the sound. The ROM-con. Fuck. God damn it. Anyway, our purpose right now, before we get into the nitty-gritty of how the circuit is working, is to figure out what's going on under the chips where we can't see, and that'll help us identify the unknown. There's one unknown chip, and it's possible that that unknown chip is part of the problem, although I'm not totally sure about that. I want to see how it's using those transistors as well. So let's just find an area of the board and start sussing it out. We need to find an area of the board where I haven't filled in the stuff underneath, and that would be any of the chips. So we'll jump in under this 3046. This is the 3046 is our first smoking gun. This is the chip that heats up in the circuit, and it turns out with a little bit of image editing, we were able to figure out exactly what the part was. I was actually short lurker using some work from a couple other people in chat in order to make like a little video image of the part number. I think I probably still have that in my downloads. Hold on. Downloads, where is that? It's pretty old by now. PDF, zip, flip. Look at this. So we were able to take the part number, image manipulate it a little bit, get some of the numbers out of it, and then overlay the actual part number on top so that you could see the similarity between the two. Kind of amazing. What the fuck is that thing? Get out of here. So yeah, this is how we figured out what that chip was. Unfortunately, just replacing the chip did not fix the unit. So I am going through the blisteringly annoying process. What's going on there? Of figuring out. Oh, I see. That one's just not connected. But there's no via right there. Why was there a dot then? No vias on. There's one on that one. and then we go under the chip and we don't know what's going on. And then this one is just orphaned. And those are the connections there. So then, top layer of the PCB, is that just some junk? That's just some junk. So there's nothing there. Okay, so let's unmark that as a loop. What? Oh, Control Z. Go into this layer. Got to make sure we're on the right layer. Select none. Go with a pencil and just on the right layer. Loop it down. No. Ah! Okay. This is what I used to do for work. Sit down with a pot of coffee and not make a nuclear bomb. Let's get that out of here. I'm going to get rid of this overlay. This is funny to have in a thumbnail. Okay, so under the chip here, under this chip that we had identified previously, there is some stuff going on. Now we've marked out what the internal transistors look like. It's very sloppy, but I understand my own shorthand. I'm not a neat writer, and I've looked at my own terrible writing for a long time. What are doing here? Ah, ground. Okay, good. I guess I could just leave both layers up, and that'll just tell us what's going on above and below. So below, we have a trace that's going out here to this test pad. So what I'll do is I'll go from that test pad, and I'll look at the pins of the chip and see what's going on. And I guess I could just do it right here. I don't have another camera to spare. It'd be nice if I could get all of this on camera. Well, we don't necessarily need the microscope at the moment, so I could do this view, and then you guys at least get somewhat of an impression of what's going on here. With no light. Lights. Desk toggle. No, not desk toggle. That was the wrong one. Turned off a whole bunch of light. Stand. There we go. I can toggle the stand on and off, but when I go to different images, it'll turn it on and off specifically. What's a henway? I don't know what that is. Henway? Never heard of that before. Okay, so where are we going from? From the bottom test point to this little goober right here. So from the bottom test point to, let's do this one, 440 ohms. Nope. That's a good meal right there, is what that is a hen that weighs that much. All right, I guess I'll just go down the pins and just see which one it is. 3.4. 1K. What I'm looking for is ohms. I'm looking for something that is in the range of ohms. And it would stand to reason that it would be that pin right there. 1, 2, 3, 4. 1, 2, 3, 4. My hands are cramping up. What are my glucose levels are really fucking with me today. It's causing cramps. Oh, I found it. It's on the opposite side of the chip. Missed all the atomic stuff. We're not making a nuclear bomb. I don't know who told you what. You guys got bad information is what you got. Well, I found it and then I unfound it. Okay, so it's the one with the trace coming off of it on the other side. So that trace that we routed to there comes out here for some reason. So on the right layer with the red, I'm going to come in like this and just go down to there. I probably should have put the chips on a different layer too. Then I could have added a different color marker for that so that so I'd see the traces on the board, but whatever. So 47C4 goes over into this pin, which is associated with this transistor's collector, and it goes down and under, and it goes right past that. Why would they do that and not pick it up over here? You could just put a via like here. What are you doing? That seems a little weird. I'm going to test from the test point from these two pins right here. I'm going to see if those two meet up. Because they should, unless something is weird. Here to here. Yeah, I get 0.6 ohms. What a circuitous thing. This might be due to the way the schematic is presented. Strange. Okay, so at least we know now. That's that connection. What are you doing? What is this one doing? I don't know what it could do. I could test it up here at the 101. I could test it up here at, well, possibly that pin. I'm not sure if those meet up. Because remember, there's a little bit of parallax issues and fisheye issues and stuff. Things don't line up exactly. We don't have a orthographic, perfect view of the top and the bottom layer of the circuit board. And you'll never get that unless you have a camera that's like a mile away with a super duper lens on it. You don't need that kind of equipment to do basic reverse engineering. You don't even need to write neatly. So this one is a bit enigmatic until we can figure out whether or not it's connected to either of those. I could poke in the other side of the PCB and actually like get the via to conduct. But what I think I want to do is I want to test. Well, what do I want to do? I mean, it's weird because we know the part number of this part and it just seems like it's wrong, but it shouldn't be wrong. It's almost a thing. Why did it jump like that? I didn't touch my mouse. Why did the image jump? I hate it when stuff does this. Oh, probably because the scroll wheel. These SteelSeries mice, you can be on the cusp of clicking over the scroll wheel, and so if you move your hand away from it, it seems like you're not touching it, but it accidentally clicked the scroll wheel one bump over, and so everything moves in a weird way. So there is definitely a trace there. We know that one's connected. Let's take, well, where we can take. I mean, we can either do the transistor. Let's do this one right here. Let's do the 101. I'll put this up on the multimeter, or on the microscope rather, on this scene, because then you'll be able to actually see what I'm probing. Multimeter? Well, it'll be nice. Well, we'll just go over to the other view then, because that way I can show both items. I can show both the multimeter and my hand position, and I can show where I'm probing. Where I am probing. So we're probing here. And I'm looking at some of these over here. Huh, the screen's looking a little dim. I wonder if I maybe need new batteries in my probe, in my meter. It doesn't say I'm running out of batteries, but 1.3 ohms. So we are connected to the one that goes there. Look at that. Why would that be connected like that? Well, let's mark it down. So that one goes to the one with the test point, which is right in front of it. So, and that's doing it on the top layer, and then it goes to a via here. Okay, cool. That answers that question. Does it go anywhere else? Would it go anywhere else? I don't think so. This one is still unknown, but so we've got this one's connection. This one is going somewhere. I guess I can see if, for instance, this pin here, because this can go right here and not hit anybody on the top layer. I should have done the chips in a different color, huh? I want to see if this pin right here has continuity to this pin right here. Let's try that out. We're getting all of our eggs in a basket, basically. We're just shoring up all of our stuff. So that would be this one and this one. Ah. Oh, there it is. It's the third one down. Well, that's a totally different gate. All right, so that one goes the third one down. I'll also have to rule out whether or not pins are connected to each other, like one for one. So this one goes on this layer, it goes over to there. Well, that makes this one difficult to route. Could it be going up here? Crossways? Because, like, if we were to believe that the datasheet is correct, oh, this is the wrong part. If we were to believe that the datasheet is correct, then I probably should delete all the chips on this. No, we've already made so much progress, I'm not going to do it. I'm not going to do big changes, but I really should have had 3 layers. It should have been chips, top layer, bottom layer. If we're to believe that this is the schematic, or this is the internal of the chip, then this is not being used for anything. And this one's doesn't have any connections either. And this is the base of this transistor. You wouldn't really be caught hooking that up like that. What if I'm probably using these to oscillate against one another? So there might be some freestanding like collectors because they might be using the bleed. No, but they're not making noise. All right, so let's test this one, or no, this one rather, and see if it's connected to any of the other pins under the chip. So that would be this right here. And then I'll test it across here. That, is the battery light on? Why is it so dim? Oh, it's just the angle. It looks a lot better for stupid LCDs. There we go. Well, there's a little bit of the lamp in there. I'm lamp lighting everybody. All right, so from here, we test over here. What? Okay. So just, okay. Well, the first one we tested was a confirmation. And guessing it probably doesn't go to any. If this is a supply, then maybe we'll see it in multiple places. Doesn't look like it, though. Okay. Cool. Well, that was very quickly answered, which fills me with suspicion. It's like, I know what I'm doing well enough to know where to guess, and apparently answer my questions in a little bit too timely of a manner. You know, I billed like an hour for this. Just drink coffee? Okay, so those two are connected. Pin 14 and pin 6. In order to make this, you know, this would be a lot less painful if I did this properly. Oh well. So this is going like this. It's making my drawing terrible. This is what I'm talking about with like redrawing these things. You draw it again, you draw it again. I live, I die, I live again. So for some reason they have the collector and the base linked together. I get that's a strange thing to do to a transistor. It's a hard way to live. And then it goes over to this transistor over here. If that's a transistor, it might be a diode, who knows? Okay, okay, okay. All right, mysteries, mysteries. What other mysteries do we have? We got this one right here. That pin right there, this pin right here. The base over there, the bruise right here. 2 6-packs and a big bag of ice. But this thing is already being blocked by this. Could you stop doing that? This thing is being blocked by this trace right here. So it has nowhere to go. But yet it is connected. Yeah, the scroll wheel going up and down is really annoying. So what are you doing? What is going on? Some of these pins are actually going to be floating, I think, just because of the way oscillators are designed with transistors. Everybody seems insistent on making a sine wave in a particular way. Nothing? Nothing? Nothing. Nothing. And then, just for reference, this loops down and around, and I think it eventually goes to, like, I don't know, one of these? I forget. Down and around, and like to one of these guys. Whatever. Where does it go? Well, it goes here. And if I poke this really hard, I don't want to damage the silk screen too much. All right. This one here. Fail. 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 You'll notice where I'm poking it is where I can dig the point in behind the pin and get a little bit of pressure on it. Fail. Fail. It might not be connected. And we're kind of out of like external connections. We've sort of mapped all of the external connections to pins, so okay, as far as I know, that is a no connect, unless there is a line that somehow makes it out of here that I don't know about. But on the other side of the PCB, there's nothing. And we know where those other two connect. We know that it's not connected to this part of the trace. We're also, wow, that red is it's kind of dazzling. It's a little bit dazzling on the lighter green. Yeah, it's only a 2-layer board as far as we know. There are some blind vias, but I don't see any evidence to prove that it would be a 4-layer board. There are a couple areas. Oops, wait, hold on. There's a couple areas, if you look closely, there's some spots where there's just like a via out in space, but I don't see any vias that are on this layer and don't have any connections, aside from things like these test points. So I'm pretty confident this is not a 4-layer. I don't know why you would do a 4-layer board in a device like this, because it seems like they got everything done that they needed to with 4 layers. It doesn't appear that they're doing anything too fancy. And if you had 4 layers, boy howdy would this look a lot different. I think there's just some leftover orphaned trace and via stuff going on. Where was that one? There was one that was just hanging out. It was just this via that was hanging out. Like there's 2 of those. Where'd it go? It's like when I want to talk about it, it's nowhere to be found. We figured out that if the car was ever mentioned, if you say car or if you spell car, Willow goes downstairs and hides under my desk. We didn't know that we taught her that word and to spell. But if you mention a car in a certain way, she will just walk away. She'll just be like, I'm not really needed here anymore. See you guys. She does not like car rides. I wish she did. What's wrong with adventure? Okay, let's get back to what we're doing. So this one is not connected anywhere, I don't think. I could probably try to trace it to like power and ground, but I don't think that's really necessary. Above the silver cap in the middle. Silver cap in the middle of the board or of the what we were looking at. There it is. There you go, good eye. Yeah, so this is like a totally orphaned via. And those are usually indicative of a 4-layer board, because if you're doing layer transfers for traces on the internal layers of the board, not the external ones, you still have a via that goes through the entire board. Sometimes you can do blind vias, but they're absolutely aggravating as all hell. That's where you do the vias and then you coat the copper on top of them, and they're not visible. They do things like that in like motherboards and like really expensive electronics, but blind vias are a nightmare for the person troubleshooting the circuit, so you generally don't want to do them. So if you do a via on a 4-layer board, you need to make sure that the top and the bottom layers are clear for it. In the case of if you see something like this on a PCB, either it's a 4-layer board, usually that does mean it's a 4-layer board, or something about the design was altered and they just left the via there and they didn't see it. Because on the other side of the board, it is just a via to ground, and sometimes you put these ground vias in because you want the CAD software to flood fill an area with ground, which stands to reason. Maybe you wanted to have ground in this area, and then they decided that they don't want a ground plane on the entire board. So they got rid of the ground plane on the entire board, and they deleted a bunch of those, you know, orphaned vias that would bring ground to ground, and then they didn't follow up, they didn't find this one. Transceiver board is blind vias, oh God. How do you, yeah, I don't know. I just don't know how you would work with that. The other thing that I don't see, and I only see it for test points, is something like this, where you would have a via that's surrounded by nothing. And that would tell you moderately definitively that either there's something they missed in the design, or that it's a 4-layer board and it's getting to some internal layer. But I don't see those as prevalently. I need an example of a 4-layer board that I can grab. Do I have any? I don't know. What do I have sitting around here? In Reach, can I find a 4-layer board? A 4-layer board. God, why do I talk like this? I can't. I don't see anything around me. So yeah, let's get back to what we're doing. So we're figuring out some of the traces on this super matched RF transistor thing. Can you tell it's multi-layer by looking at the side profile? Generally, no. if you're real good, maybe you could do that if you know exactly what you're looking for. But the 4-layer board versus a 2-layer board is not necessarily visible. Sometimes it can be, but it's not very definitive. This is 2 layers, right? Is this thing 2 layers? Yeah, this is definitely 2. This thing was made very cheaply. It's just a breakout board. You know, sometimes you can. It depends on the fiberglass that they use, but generally you're not really going to see it. It's very, very difficult to see. Okay, so going from this chip right here, it's covered in dog hair. I'm sorry, Dave. You knew the environment it was getting into. We have more traces here on my utterly bonkers tracing of everything. So we have this one here that is a mystery, wrapped in an enigma. Wrapped in an enigma. Jeez, language words. What's going on here? Well, this is a connection. Supposedly, it's a connection to 2 transistors that have other connections. And by the way, one of the big enemies of what we're doing right now is if there are other connections that I didn't foresee that are connected under this. But so far, God, it's so hard to see what's going on with this. I should probably throw down like a 3rd color on this and just do the chips in like black. I should have done that from the start. We're going to suffer through. This is going to be a little bit confusing just because I didn't add enough layers to this. I should have added a 3rd layer with chips. And I'm going to keep saying that because every time I look at it, it just bears mentioning. Because if I know intimately what traces are under this board. I know that there's a trace that comes up and over here. I know that this one comes down and over there. This one goes up and over. If there are other traces, we do not know about them yet. We know that this one does not connect to any of the other pins, even the ones next to it. So we need to check that for this one and make sure, because this one has to go somewhere. And we'll pick it up at... We don't know where that goes. Damn it. But wait, that one, okay, that one connects to here. We need to see if this pin connects to this pin. We'll just test them all. So we go to this pin that looks completely on its own. Test it against you. 500K. Nope. We already tested that. 0.6. So this pin is going to this pin. That's one that goes all the way up and around. How does that connect? Wait a minute. What the fuck? How does it... Wait. That can't connect. What we just learned. This is connected to here. But that would go across this. So this to... Wait a minute, which one? It was... Oh, so maybe it just meets up with these. The one that goes under and around to... World is a... Wait, what does that mean? The world is a duck. Born to test pins. Yeah, you know. Yeah, it's... I did this to myself as a challenge. So from the one that we're looking for, which is the base of the transistor on the left there, the bottom left, and that would be 3 pins up, 1, 2, 3, right here. I go to the exact opposite of the board, and I get 6M, one below that, and I get 1.2M, one below that, 1.8M. Somewhere in here, there's a very confusing pin thing going on. Am I on the right one? I may have just tested the continuity of something we already know. All right, sanity check. Hold on, I'm going to start over. Oh yeah, desoldering it would make it much easier. It's just I don't want to damage any of the pins. And actually, we had it desoldered yesterday, if anybody wants to go through the VOD. Actually, to be fair, we've already looked at it. So why don't we just utilize archive, my abilities to archive to our advantage. So let's just go and open up in the desktop, in the recordings folder that is slowly tanking this machine. We have yesterday, which would be 516 rather. Who the fuck is that? Mute. Mute. All right, where am I desoldering? Is towards the start of, was it? Oh no, it wasn't this stream. This stream we actually went right into reverse engineering. It was the one before that. On the 14th, on Tuesday. Who the fuck? That was the big raid. Did a little desoldering. So where am I soldering? Vacuum tubes, talking about pinouts, buffers, this thing, that thing. And then we went into, here we go. Where am I lifting the chip out? Oh, this is the censored one. That's the one we replaced first. Oh, we can, oh, that's good data right there. That's good data. Let's just get that marked down while we're here. Mark that down, mark that down. So this is at the top of the, what could be a diode ladder. We're not totally sure what it is yet. Top of the diode, Officer Krupke. Where is that? That is thing, and then that. This one. And so now we know that bottom pin goes to a via. Well, that's not displayed there. So let's get into that layer and let's add that via in there. So this one goes to a via. Where does it go to on the bottom of the board? Wait, but there's no, Oh, I might be turned around then. Hold on. Make sure I'm not turned around. Let's just delete that. Hard to delete stuff. Is there an eraser? I think one of these tools is an eraser. There it is. There we go. Okay, whoops. Jeez. Still learning how to MS Paint my way through this. The chip that we're looking at is this transconductance amplifier, and it is currently facing... Okay, so I'm looking at it upside down. Am I? No. Yes, I'm looking at it upside down. Okay, so upside down wise, there looks like there is a, maybe not a via there. This is the upside down view. So on this pin, there's a via. Double check with the board. I don't see nothing. Why is there a single line right there? I was clicking around and hit that. Oh no, that would be on the opposite side because it's 180 degrees, right? So over here, well, there's already a via there. Why does nothing add up? Why do these electronics do this to me? Why do they do this? That one goes to a via. Okay, so yeah, that's marked down already. Then there's another via here. We got that. But then, where are we? We are 1, 2, 3. So the second pin, this one right here, the one above that? No, there's no trace on it. The one that goes to the resistor, below that. Oh man, this is really messing me up. Sounds fun. You know, I can't show all this stuff at the same time. Oh yeah, you guys aren't looking at the, sorry, that's my fail. I was looking at the two different displays. I'm sorry. This is the chip being removed. I must have switched scenes or something. So the chip is out and it's sitting right there and we can see the traces underneath it, but it's flipped 180 degrees, and so I'm trying to figure out exactly what's connected where. And I'm like face into this drawing that's all like difficult to see. So this pin is the one in the lower left. I'm just gonna flip the screenshot so that I'll take a snip of this and flip it upside down. That'll be a little bit easier. Can I transform in this? Tools. Edit. No, I don't want to edit with Paint 3D. Fine. Do a quick paint document. As if I needed more programs running on this computer. Good enough. Rotate 180 degrees. We don't want to flip it. I want to rotate it. Oh my god, chat is speaking in tongues. Okay, so over here, now I have the right side up image of this thing, and I can see these traces and vias and stuff. So okay, bring that over to the other screen, close the snipping tool. We'll start it up again if we need to. And then we don't need well, we do need the video to get the other chip. I'm gonna move that way over to the other screen. And then talk through everything you're doing. This is how you stream. So we got this via here, that one's already known, but there is a trace coming out of that, which, boy, I really should, I'm gonna put it on the lower layer, even though it's not there. That might confuse me later, but it's just gonna, it's gonna clean up with all these red lines right here. I'm not gonna be able to see what's going on. Control-Alt arrow key to rotate your screen. I never learned those. There's a whole group of shortcuts like that. I don't really want to rotate my screen in Windows. So it's 1, 2, 3, 4. 1, 2, 3, 4. No, that's wrong. 1, 2, 3. This one. So this one goes to here. Oh, I'm on the wrong layer. We'll do it on the bottom layer, even though it's not there. Like this, and then it goes down to this via down here, like that. That's that trace. And then from the second one down, the one that goes up to this cluster, we come out here to the via, and then to this pin. Not the one that goes at this one, so it goes to this pin. And I'm just gonna have to remember that it's on the bottom layer. And there we've got the via there. Okay, this is clear as mud. I know this is very confusing. It's hard to look at, but it is representative of what's there. We're gonna clean it up. That's the whole part of the process that we do here. We then clean it up. Where did my video window go? That's not the window. Oh, it's all the way over there. Bring that back over here. Okay, so there's that chip. That one didn't fix it. So we then desolder its buddy, the transistor. Where did we desolder the transistor? There it is. So now we know what's going on underneath that thing. I'm gonna snip that. Hey, that gets us on pretty easily. Why is that, 7L? Why is that? This is what I do when I make the thumbnails and stuff. All right, cool. So we got that. We know what's going on under that. Close that. And then we go to the chip that it is, which is not there. So now we definitively know what's going on underneath this mess. Bless this mess. So we have the trace that came from underneath the chip. And it apparently does not do what I thought it did. So I'm going to undo, I'm going to use the eraser in a very select manner here, and I'm going to undo the mess that I've created here. In fact, I'm going to highlight everything under the chip and start over. And that means redrawing all the transistors. Oops, wrong layer. Okay, so I'm not going to do it in another layer, because then I'd have to do it for everything. I'm just going to redraw the transistors. So let's open up the schematic of that chip. That chip is the something, 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 something. I totally remembered it. It's the one with all the transistors in it. Not that one. LM3046, maybe? What are you? Yeah, LM3046, okay. Actually, I could consult the video that I opened earlier. This is how we figured out what it was. Ah! LM3046M. So that's what it was. Got too many windows open. I'm gonna close MS Paint. Save. Move the snipping tool over to a blank spot. Whew. I got a lot of stuff going on in front of me right now in order to figure this thing out. So we know it's an LM3046, and this is an LM3046. And this is what's inside of an LM3046. Now, if I was crazy, I could highlight this and cut and paste it into the actual chip outline, and then it would look nice and organized. But instead, I'm going to just freehand draw it in, because I'm crazy. Now, what is the marking for pin 1? It's just like a 45-degree angle on the outside of the package, right? For the SMD version. Lead number 1 indent, they have marked, but then they have an angle on the side of the chip, and I'd have to go way back in the archives. Actually, there's an image somewhere of this PCB, so let's look up the... because they didn't put any silk screens on this thing. We don't know what's where. We're not doing the big book today. Acid Labs, M303, PCB, images. There's a nice high resolution-ish. And there's somebody with a similar problem where the part's gone bad. Did we put this thing in backwards? That's the wrong one. Okay. I was like, yes. No, we put it in the right way. So we have it correctly with pin 1 on the upper left hand. You can see here they tried to hide it. We figured it out. But unfortunately, that's not what broke the synthesizer when it was plugged in wrong. So we need to get deeper into this. But we know where pin 1 is. Pin 1 is in the upper left. Huh, I guess I installed it wrong when... Oh, no, it's in the lower right because, yeah, this is upside down. Okay, cool. Okay, so upside down, we got that. And then this is from the same view with the potentiometers on the left. And so we know now what the internal connections are. So let's look at this layer. So there's that there. That via there is, no, it's 180 degrees. So towards the bottom, we have, well, let's just go from pin 1 so I don't mess myself up. So pin 1 goes out to this via. So I'm going to take my layer 1 in the layer 1 color and go up and over. So that's totally different from what I saw before. Up and over. Then pin 2 goes out to a bunch of other stuff. Pin 3, that looks like it goes, yeah, pin 3 goes internal to pin whatever that one is. So pin 3 goes, well, that doesn't look right. Wait a minute, hold on. 1, 2, 3, 3 goes over to 2. But 2 goes out there. But I don't see those on pin. Oh, no. Okay, yeah. So it's this one goes here. The spatial acuity is beyond me sometimes. Things just tend to get really confusing when you're flipping things around in your brain. You're supposed to be looking at it in a different, perspective, etc. But yeah, it messes you up. It's 1, 2, 3, 4, nothing. 4 looks like it's just floating, even though there's a via there. 5 goes down and to the right. 1, 2, 3. Wait a minute, what? No, I'm counting this from the wrong side. Hold on a second. I'm screwing it up. 2 goes out, okay, this way. 3 goes to 2. 2 go. What is going on with my brain today? I'm gonna get this into MS Paint and flip it over. For some reason, it's just killing me. MS Paint. So this is what I should be filling in under that chip. Okay. Now I know. Close that. I don't ever want to see you again, you confusing piece of shit. All right, get this, fill that in, just so we know the outline of the chip is there. I will have to do the transistors later. I'm not going to write them down on top of this because it makes it way too confusing. So 1, 2, 3 are our vias, And so we start down at pin 1, which is connected across, just like I had before. Let's clean this up a little bit. The pencil. Ooh, look at how shaded that is. Pin 2 goes out and over. 3 goes like this. Well, more or less. Next one is blank. This one's blank. Then this one goes to the via. Next one goes to the internal via, right, or this via right there. I'm going to circle those. The one across from it does not. This one appears to do nothing. Nothing. Then the one above it goes up and over. So up and over to this one. Above this goes up and over like that. There we go. That's kind of hard to, it's hard to ascertain this kind of data when you don't remove the chip. I wonder if we should just pull the other chips, just say screw it, and we pull the other chips so we know exactly what's going on under them. Maybe that's something that we'll just do, just because I have the hot air set up. So this one's now on the chopping block. We'll figure out what's going on underneath it. And I suppose I could remove all of the internals like I did with this one, and then we can fill them in. Yeah, we're going to do that. It's just going to make it a little bit easier for me to figure out what's connected where. I'm going to blast you with my hot air. What did I remove? Did I mess up and remove something? No, just rectangle select. Okay, so rectangle select here, go like this. We'll just knock out the internals, and then we'll pop the chip up. I should probably do that with the other one too while we'll go get video evidence of it later. Select nothing. And let's take that 074 out, 7804 out of there. This is going to take more time and it's going to be more involved, but at least we'll be working with our hands this Friday and breaking our brains. And that way I definitively know what all of the circuit board connections are, except for under the capacitors, but we can figure that one out. Those will be the ones that we can probe. So yeah, let's get that. Let's arm focus. And we're doing the 7804. I'm going to move this stuff. Move my stuff. Grab you. And I guess I'll want to put it up on the vise so that it's not like shaded and shadowed all weird. Take the vise, take the IDE connector, and just use that as something that we can squish without ruining the pinouts. That'll just hold it there. I just have to be careful not to get hot air on the IDE cable because those things fold immediately. Although we could have used the Wexo sent in vise, but I like my little machine thing. We just have to make sure that it doesn't get exposed to hot air. Okay, so now we're removing this one, and we're going to figure out what's underneath it. I guess I could do, because we are, this one we know, this one we do not. Luckily, that one was never covered over. And pin 1 is on the right, even though, yeah. So let's hot air on, power on. And then I guess what I'll do is I'll just take a screenshot of this. So I'm going to have the snipping tool ready to go. And if we do it right, I can just place this thing right back down where it was. With the snip tool ready, and then we heat up our stuff. Looks like there's a lot of flux in the area. I should be able to operate properly. And with that, the added weight of the machine vise, I can then grab onto this. Move down slowly. How's it been, Fat and On? You haven't been around. You've been doing stuffies. You're getting into RF, which is crazy. RF is just crazy town, USA. Now we can see the flux boiling a little bit there, but I want to give it a little bit of time to get heat in there. I don't want to lift these pads. Oh God, we're already starting. Lots of work, yeah. As is typical. Okay, let's get a shot of that. Probably need more space than I need. Larger shot. Hold on. You guys can't see what I'm doing, but That'll do. Okay. I'll let the board cool down while we do this. And are we still flipped 180 degrees? No, we're in the same orientation for this one. Good. Okay, so my reference to the other side of the board, I need that. So now we know where those vias are, and we can mark down what's going on. Have you talked to anybody on like the other side of the planet yet? That's always fun. A fun thing. Fun, fun, fun. We have fun here. Fun. Ha ha ha. Fun. So that one skips down one. Like this. And then this one comes up and avoids those two and goes up this way. And there's no via here. I think I was, oh, that's part of the part number. I am from the other side. I meant over the radio. I didn't mean over chats. Hollander. What do you call them? Is Hollander correct? Hollander? Hollander. This goes here. That's a via. Then this one goes up like that into the via. Then this one magically has a via right next to it. I guess that looks connected, and I guess it is just like that because the two pictures of the boards are off by a bit. Oh, still, my family is actually Dutch, not like Pennsylvania Dutch. Pennsylvania Dutch just means German, but apparently my somewhere in the genealogy goes back to the Dutch. Oh, I like drugs. All right, so this one goes here, and then this one does go to that pin, but then it also goes here like that, and that's all she wrote. Wow, that was a lot easier than ohming it out. That was a lot easier than using the ohms tools. It is unfortunately very easy. All right, let's remove this one and we'll put the other one back while we're there. Bonk. I should have done all the internals on a different layer, but oh well. Let's do some hot air reworking. So we put this one back, and hopefully we can just drop it into place. Grab the chip. Make sure we're nice and warm. Hot and fresh, like a pizza. All right, I'm gonna get the tweezers out of there. I'm gonna let it solidify a little bit. And then we'll come back in with the hot air and let it settle in. What's up, Copper? How you doing? We're being a little bit more physical with our reverse engineering and removing chips in order to see what's under them, which is a little bit much. It's not something that we used to do in my old jobs, but we do have the ability. I mean, I've got the hot air right here, so might as well. This is not something that we would typically do because this could be a destructive process in a way. It can be a little bit destructive. Oh, but this thing is broken, so what do we have to lose? Is that really molten? What's going on there? I'll come in with the iron and clean that. Oh shit, it was still hot. Son of a bitch. That's probably solidified by now. No, it's not. Oh my god, it's really hot. That was way too much heat. Oh, now it's solidified. All crooked. Oh, jeez. Let's hit it with some flux and then maybe I'll come back with hot air, but that was way too hot. That should not have been molten for that long. All right, just a little bit of hot air on it, and then we'll nudge it back into... It'll either correct itself or it'll nudge back into place when I heat it up. The other part is that we're going to have to clean all this stuff up, and oh well, we made our decision already. Yeah, I'm trying to keep this visual and punchy and fun instead of just sitting here and ohming everything out. So that I guess that's okay. but I don't want to ruin Dave's lovely module. I added lead to all the solder for you. I knew that's what you wanted. Now let's shift it over to the right a little bit, and I kind of want it to be a little bit more centered, but I don't think I have the dexterity in my left hand to make this happen. I'm gonna burn the shit out of myself. Son of a bitch. There we go. Good enough. I'm gonna let that cool so we don't nudge it out of the way again. Meantime, I'll put a little flux on this one. Now we did take this one out before. I don't know where the footage is of that, so I guess we'll have to do it again. I know, you guys are a bunch of freaks and you enjoy the boring parts, but I do have an obligation to keep it punchy, just so that people watch what I do. So we get enough people in here, and I can keep doing this. Not that it's under threat, but I mean, it's, you know how it do. The whole Twitch thing. I am glad that you guys find this fascinating, and some of you find ways to help me with it, and all that good stuff. That is very much appreciated around here. All right, so let's heat this one up and pull it. Just kind of want to keep I want to heat the board up too. I want the board to get to sort of a base temperature so that I'm not shocking things with sudden temperature changes. Dislodged a cap next to the chip. I'll check it in just a second. Sometimes the stuff in the area, when you use hot air, everything gets hot. Believe it or not. We can fix it. We can fix it. Yeah, SO8 is nice and forgiving. Or SO sized, rather. Nice and forgiving. Boop. There we go. Reveal to me your secrets, oh chip of wonder. All right, where's the offending cap? Ah, there he is. We can just solder that one. Everything in this area of the board is like piping hot, so it should solder pretty easily. Might even be able to do both pins at once just by heating through the cap. And again, this is part of what you have to watch out for with hot air, is things walk. Ow, things are also hot. Tweezers are hot. Let's add just a little bit of solder in there. Good enough. All right, so now we can fill this in. And I'll wait, what was this one? Oh, this is the one that we just removed. Oh, thank goodness. All right. Microscope, let's do this. There we go. So one is ground up at the top, and that one connects to that pin as we'd expect it to. So take the pencil, go like this, oops, go like this, make sure that that looks connected. The one here is part of a longer trace that goes down into, well, this one goes here. That was predictable. I'll do a little one of these. Then this comes down to, these are connected. And this one goes up to there. This one up and around to this one, which goes out to 2 capacitors. This just goes direct. We should make it actually connect like that. Yep. Do a little circle down like that. Just make it a little less confusing for me later. And then the second to top goes to that one like that. They're off by a little bit just because of the camera setup. And then that one goes straight down to there. Up and around. We got that, we got that, we got that. Okay, so that's that. So now we know all the connections to this one perfectly. Recently gotten a few ads for hot air beds from AliExpress. I'm not sure. I'm not sure if your device has heard me talking smack. Heat it up, heat it up, heat it up. Now what I could do is use desoldering braid and stuff, but we're playing it fast and loose with the rules here. We may MS Paint the schematic. I might do that just because CAD was going to be a lot of messing with part numbers and stuff. I just don't want to do that. CAD, of course, would be a little bit more malleable. I'd be able to change things much more easily. Ooh, that was way too much heat. But if I let that solidify, I can then remove the tweezers and come back down here with, hot air gun almost knocked over my multimeter. Is something that I can say that's a little weird if somebody else says. Oh no, the schematic diagram is going to be black and white. I have a certain way that I do things. All right, that one's in there. Dave is none the wiser about the temperatures that his device has seen. Make sure these are all flowed. Putting the iron on, I'm just making sure the ones with the sharper creases are actually soldered, because you can sometimes run into cold joints with stuff like that. Just want to make sure there's no cold solder joints. Okay, that is that one. What's our next enigmatic chip that we do not know the underside of? That would be this one. Dun dun dun! Okay. Dramatic zoom. So let's blast away the interior with piss. And then we'll remove the chip. This one we have removed before. I do not know where footage is of it. It's probably like a couple months ago to maybe a year ago. Whenever Dave dropped this thing off, it was one of the chips that we replaced, I think. We did something with it. It might have been one of the ones that was scratched off and we sleuthed out what it was. This area of the board is already quite hot, so this might take less time than we think. Like, in fact, that was quick. That thing just gave up the ghost almost immediately. All right, so we got a bunch of vias here. We just need to replicate them. Let's get the scope a little closer. Damn it. What's going on? Wait, what's going on at the top there? Okay, so it's just straight over and then down. The rest I can see from the distance. So that one's proven. Put a big blurry mark on that. Then this one goes here. This one goes down to the second. No, it goes all the way to the one on the right. So it's like this. Then this one. Wow, this would have been very difficult to figure out. This would have been a lot to figure out. We could have done it. We would have done just fine, but this is much more definitive. This should not be on top of this one, because this one actually goes here. So let me erase this area and just like, I'll just leave it, select none, and then go from here to here, like that. It's not as good as if it was positioned correctly, but nothing is connected to this pin. I should put like an X through it, but, and then that one goes out and around the ground. Okay. Okay. I see it. I see what you're doing there. Let's see. Are any of these others like connected internally? Like what's going on right here? No, it's just flux. Yeah, there's not like a trace inside there. Well, the multimeter will know more than scraping will. The multimeter always knows. Ah, the board just fell in a little bit. .6. So yeah, that is connected. This one and this one. Although if they were connected, why would you design it the way like this? But no, they're not connected. Okay, so those two are though. The one that has the via going into it. So we got the via going into it. Oh, and I got that anyway. Okay, cool. All right, so that chip is done. That's the digital switch or whatever it is. So we need to put that one back. We do that with hot air. Trying to get my finger into the tweezers in order to splay out the blades. And then when you let go, they'll spring back down onto the chip. And so I want to solder one of the, hold on. I moved my mouse in such a way that I couldn't see the microscope anymore. I want to make sure that this thing is touching the board. Pop, now it's touching the board. And then I'll get a little bit of hot air in there, but I'm going to keep hot air revolving around it until this starts to, oh, it started to solder in already. Let's get it in position. I especially do not want to move this thing while it's only soldered to a pin or two, right? You want to make sure that this thing doesn't wrench up any of those pads that aren't connected to anything else. All right, so now I can come in with hot air and just slowly heat up the entire area. You saw when I actually got this thing close enough to tap, it almost immediately soldered. So I could do operations fairly quickly with this, but I don't want to crack anything. I don't want stuff to expand in a weird way and crack parts of the board. It's not that common, but it is something that I'm worried about. Whoa, I just tapped the whole thing and it moved. Oh God, I gotta watch out. I think this is probably fine and it's all well and good. I'll just bop it on the head to make sure that it's seated. Okay. Well, now it's to the right. Before it was a little to the left. And it's evident when you look at it from a distance. Looking at it under the microscope, it doesn't look so bad. But when I look at it from a distance, I'm like, man, those are some long pads. All right, anyway. So now we know what's under that one. Our drawing has become just a little bit better as a result. There are other spots where we don't quite know what's going on, but that doesn't garner removing entire components. Like for this, we can figure that out with ohms. There's only 2 pins there. There's not many ways for that to escape that area. Unknown chip. This is an important one. Pin 1 is to the upper right. We want to make sure we remember that. Go over to the grave of the unknown chip. There it is. There you are, you little bastard. There's not much that this thing can do, but at least we'll be able to mark down precisely where all the traces are going. I should have mailed this to Applied Science and had them x-ray it once. One little x-ray, and we would have been able to do this in 10 minutes. This would also go a lot easier if I had the components in CAD. We're not going to use CAD. We're not going to use any kind of an advanced image editor. We're going to use MS Paint. MS Paint. and we'll figure out what all the connections are, and that should help us identify by connection what this chip is. So let's go actually to the microscope view so you guys can see where I'm waving my little hot air gun. I mean, my big girthy hot air gun. What do you mean little? Get the solder out of there. This thing has to have some kind of a crazy heater in it. But the content, think about the content. No, content of me entering parts into Fusion 360. I mean, like, it's great to show how frustrating it is, but other than that, I'm not jazzed about spending all my time entering individual components in. Unless they're already in some kind of a library, but I don't think they are. This does not have any flux on it. Ah, the resistor. The atmosphere. Ah. Oh, it's on the X-ray. Ah, yeah. Well, who knows when applied science would get around to it, right? Or if he'd even heed my call as a fellow content creator. Some people are super cool with that kind of thing, some aren't. So, who knows? Who knows? I'm going to fix that resistor before I move on. I would certainly love to get on that guy's radar because he does some really cool stuff. But I'm not exactly as clout farmy as these people are. These people are way more famous than I am. I'm nobody. I'm nobody, and they're nobody to me. You know what? I'm way cooler than them. This is my castle, and I'm king. Yeah, I'm like nothing. I'm like nothing to these guys. I'm adding a little solder because I need to bridge up to the resistor. I can't get both leads to stand down flat. See that, how it's shifted right there? Solder rework, la 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 la. Of course, if you hold on one of the pads long enough and this design is insulated enough, you will transmit heat through the resistor, even though it's ceramic. He hasn't uploaded anything in 8 months. Sheesh. Probably has a job of some kind, right? Okay, so let's get this down onto... There's a lot of stuff going on under these chips, man. They did a lot under the chips. You never know with these people. Like, I emailed Erica since, and I was like, please, I need a hex file, and they never responded to me. Whereas I send a message to somebody like Toil, and he immediately responds with, they immediately respond with all kinds of information and things that I could try and ideas. It's really cool sometimes, but other times you just get nothing. You just get nothing. That one connects there, this one connects there, that one connects there, this one connects all the way over there. So let's get the red pen and let's go over. Let's get the question marks out of there. I know I don't know what this is. I don't need to remind myself. Select none. I gotta be careful because if I move my hand, like wrist over a little bit on the bench, I might accidentally contact the hot circuit board, burn myself. This hot air is, you know, you wanna be careful around it. It'll make you lazy. It'll make you lazy, and when you get complacent and lazy, accidents happen. Scars are cool and everything, but, you know. Really, that one just jumps over this. That goes like this. And then this one goes here, via, and then over there. Burn the subs, not burn the streamer. They want it to be burn the streamer. They're after blood. I know these people. I made a bot with a tank, an X-Acto knife on it. An X-Acto tank, if you will. They wanted to kill me. They were out for blood. For blood. Hold on, I'm trying to keep up with what's going on. I need to see my Streamlabs. Make sure that people aren't, like, there could have been a 500-person raid. I wouldn't know. There wasn't, because I'm not cool enough. But cool. All right, yeah, it was just Fat on with his big fat sub. That was a great sub. One of them that it's useful to have alone. Oh, have aloe vera plants in your yard. That's true. That's true. Blender for 3D CAD. Actually, there are a lot of really good plugins. You can Flatulent Gonad knows a lot about this. He's been using Blender quite a bit for three-dimensional CAD purposes. It's a little bit more loosey-goosey with the things that you can do. AutoCAD is a lot more rigid. I've been learning a little bit of Blender. I don't know how to do measurements precisely, but I think there are plugins for literally anything. If I had $1 for every time I burnt my fingers with a soldering iron, I feel bad about my nephew in here. I was teaching him how to solder, and I told him to be very careful with the iron because it was very hot. And at one point, he was reaching the iron out to go to something, and his grip loosened enough that it slipped back, and he ended up getting like a little rectangular burn on his finger. And I was like, don't tell my brother, you know, don't tell your dad because he's gonna kill me. And he took that seriously, and he actually kept it secret from his parents. And I'm like, I had to sit him down and say, listen, if an adult ever tells you to keep something secret, tell your parents. Like, never keep a secret, kid. But yeah, he was like, oh, hush, I didn't tell them about the. I was like, dude, no, you burnt your finger. Like, tell your parents. Like, I didn't mean that seriously. I gotta be careful about, you know, how we treat him. He doesn't understand when I'm joking sometimes. But he did take to soldering pretty well. He was pretty good at it. Obviously he wasn't perfect, and so I was yelling at him, and I figure the more I yell at him, the better he's probably going to be at it. But you know, I was screaming for a while, so I had to let my vocal cords rest. All right, so what else is connected here? We've got this one here. Whoa, giant pencil. Oh, I'm not on the pencil tool. There we go. Layer, right layer, there's that, and then get that right here. And so this one goes here, so I draw a little circle for it, go here. This one I need to draw a circle for, this one I need to draw a circle for. The circles are just gonna make sure that I know that it's a via, and then I've checked it and everything. Solid uncling, yeah. Uncling. Oh wait, no, that one doesn't connect there. Control Z. That one goes here. And then this one goes here. Oops, it goes here, and then it also goes here. So when you're testing this from above, there's a certain logic that you can follow. Like for instance, this trace here, you would ohm it out. You'd find this resistor and then ohm it out. And then we would find that it both connects to this pin all the way out here and this pin right here. And you figure it's not gonna be passing over all these lines. So it probably goes right here. And if there's a via there, then you're like, okay, so the engineer that was designing this went up this way and avoided that pin by going there. So you can kind of rule out where things are going to on your PCB. Obviously, desoldering it and just looking under the chip will help massively too, but you don't necessarily have to do that. In the very first Boy Scouts meeting we had, we chose our first leader. The adults quoted him what to do to sharpen an axe. Oh God. He sliced his thumb. Yeah, sometimes you get knife bites, huh? That's what like summer camp, I was like, cool, I got this cool new flip knife. And I had like immediately got a really bad cut on it from it. I was like, it's Tontoed. It's so freaking cool. Ow. Just closing it, I think I nicked my finger on it. Stupid knives. Measurements are labeled as to scale. So default cube is 1 meter. There's no like, I don't know of a measuring tool in Blender. I think there are plugins you can get that allow you to do the kind of like definitive measuring that default 1 meter, you can scale it to arbitrary. Yeah, and I don't know about snaps and scales and stuff like that, because you're going to need that a lot if you're doing like building stuff. If you're doing modeling, obviously that's super easy, and you can just scale the thing at the end. If you're making a statue of something, you're not going to worry about what exact dimensions there are. But if you're trying to reverse engineer something like an RC car, you're going to want more precise tools. And I think there are plugins that bring that into Blender. Gonad is very insistent on using Blender for that kind of stuff. And he's had a great time about it. Yeah, and FreeCAD. Everybody here loves their FreeCADs and stuff like that. I opened up FreeCAD and I looked at it for a little while and it just didn't click with me. I would make it work if I had to. And then Fusion 360 is free. There are just a couple limitations. So you can do the AutoCAD method of meticulously measuring things with a limited set of tools and then extruding it and then chamfering it. And you can be very precise, as I show on this channel all the time. But all the tools have their own little weirdnesses to them. And I think if you want to use Blender to do engineering stuff, you can. There might just be a couple little growing pains that you have to deal with. It's probably not going to be all that bad, though. Gotten pretty good, because you can extrude in Blender, so gotten pretty good with FreeCAD. Yeah, people get pretty good with FreeCAD. That's with FreeCAD, but I keep getting distracted a day after starting the tutorial stuff. Yeah, it's tough to do if you don't have strong motivation. I wonder why they didn't put the via up here. I guess they didn't have room for it, looking at the... Yeah, they kept everything nice and spaced out, so they decided to bust this pin all the way up. All right, well, let's get the mystery chip back in, even though we don't know if it works. You guys know a chip that would be hooked up like that? I don't. We'll figure out what it is, though. Acid Labs cannot keep this from us. This has become a vendetta. And I'm going to put down a little bit of flux to make this go a little bit easier. Let's get to where I can actually see what I'm doing. There we go. We're a little bit closer in so that microscope view is easier to see. Oh my God. Why are you so shaky today? Jeez. I really wish we could have gotten the internal stabilizer working on this camera. Maybe we'll revisit the lens project at some point. Before that, I'm going to fix up the milling machine, though. And, of course, Burn the Shubs needs our attention. Yet another week has gone by. The Dave synth has been too distracting. This is too interesting, and it's fun, and it's nice content, and I get to hang out with you guys while concentrating on what I'm doing and what I'm good at. This is really just is in my wheelhouse. So we've made a significant amount of progress towards reverse engineering this PCB. The next thing that we're going to do is start to write down all of the circuit elements, but we're going to do this in a modular fashion because this was designed in a modular fashion. We have groupings of circuits with functionality. The only other thing that we really need to worry about is figuring out what the knobs and the buttons are connecting to. And those are those two headers that have a ton of pins to them. So I'm going to hold myself here. I'm going to start applying. Actually, what I'm going to do is I'm just come in with a soldering iron and anchor down these pins. That way I know it's going to stay in place. Well, you want to have the soldering iron and the hot air in reach at all times. So I'm going to push down on the back here and then add a little bit of solder, and that may add a little bit of spring force to all the pins, and hopefully it'll seat itself once they all become molten solder at once. Like that. Beautiful. We can just give it to Dave like this. I procrastinated and ended up learning FreeCAD instead of working on my thesis. How'd you get good at reverse engineering? Exposure and experience. I have reverse engineered circuits professionally for 10 years for the US government, and then before that, I have taken apart a lot of stuff. They hired me because I knew somebody there. Obviously it's who you know, but then they discovered that I'm actually very good at this stuff because I've done a lot of it. Now, there was a little bit of training that they took me through, but I know circuits and I know designs and I sort of know how people put things together. And reverse engineering is knowing about how to engineer. You need to know the process. So a lot of the times it was just by virtue of having done the hobby stuff for my whole life. I never set out to be a reverse engineer. I just set out to be good at what I do. This stuff, well, not this is reverse engineering, but, you know, like building things. As anybody does. That was maybe heated up a little bit too quickly. That might have been a little bit too quick. I'm gonna push the soldering iron on the pins too, just to make sure that we don't have cold joints. There's not a lot of solder to go around on these pins because they were professionally done, so it's a little bit less evident that your pin is soldered and not just sitting. Oh, the iron's off. Boop. Bomb. Bomba. Sensual. 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 Sexy, sexy. A friend of mine went on a flight on vacation and he forgot CDs, and so he bought a random thing that was super happy music. And it was that song that's like bomba is just something that we constantly quote. Hey, Index C, thank you for the 37-month sub. Hell yeah. 37? These numbers are so big. I think we're all suffering from that sort of internal clock structure in your brain speeding up. The noise gate's doing its job. Oh, it's because this thing, the hot air station turns the jets on in order to cool it off when you put it back into its cradle. So there's probably a lot of weird underwatery kind of noise when I'm talking with that thing going. All right, so we figured out what's under that chip. Who's next? Well, we've only got one more, but we already know what's under that one. So I guess the two 8-pin chips are next. Hot spot, hot plate, hot dang. We already know what's under this one. I'm tempted to redo this whole thing because that's what we're doing. Because boy howdy is that confusing, what I'm looking at right now. And there's stuff on the wrong layers too. I might just pull this chip just because we can clean this up significantly. Let's clean this up because this looks like ass. So I'm going to knock away this entire thing, and then I'm going to go on this layer and knock that away too. And we'll go back to the top layer, select none, and I'm going to draw my square around this thing again. On the right layer? On the right layer. I feel like I need to clean up around it too. The image is real bad in this area. It's real hard to understand. Yeah, I'm just going to blow away the whole thing, and we'll fill in around it. Do I still have the image open? I might. What do I have open over here? I don't think this is the right one. This is one of the no, this is one of the ones that I desoldered. Yeah. So we'll desolder this one. We'll just do it. We can just get it to be much cleaner and more definitive. I know, right? All that work on the wrong layer. Most of the time when things get real sloppy, the lesson is just to slow down. You don't have to curse there. You don't have to curse there. Just slow down. Just slow down. A good way to do the chips might have been to outline the pads. That might have been a better way to do it. Anyway, we've got sort of our blank slate here, and we need to just make sure that everything is communicated properly. So I'm going to go ahead and unsolder, desolder, reverse solder this thing, and get that out of there, and then we'll get a new one in there. I've desoldered this thing like 5 times. What's another desoldering operation? Huh? 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 Eh? Eh. Give me that chip. Give me that chip. Oh yeah, it's this one. Listen, I've done all those tricks, but they just take time, and they're not really that worth it in the end. I've done all that stuff. It's not worth it. This one is just exactly what's on the tin. This one goes like this. And then the blue part of it goes... Well, I don't know what the blue does yet. We'll figure that out in just a second here. Actually, that is... There's a via right here. And then it goes down this end to, I believe, that via that I've already got marked in. So this one, that's kind of a weird thing. Okay, so that goes all the way down there, and then I'll do a little circle around that. And then this one comes over to here. I'll just draw a pin on that, and we'll do a little dot there, even though it doesn't drop layers, but that's not really quite the marking. And then here, with the capacitor, we have down to a via here, and then we have this one coming up and over, and then this one is totally blank. No, that's not right. It's like this. But then this one is not, yeah, okay, so this one over to a via and then down. And then we do the bottom layer in blue. Comes over here, and I'm going to draw it there, and then we'll go to the top layer. I'll draw the dot under it too. Oops, wrong layer. Even though it comes all the way out here, that's not, you know, because of the camera. And then I want to make sure that these look like pins. So I'm going to have to look at that and then draw them out like this. All right, layer, yes. Okay. This one there, and then this one there, this one there. What else do we have going on? That one goes down and over to that, and then this one doesn't do anything. And that one just sits there. And then this one goes directly over, actually technically it goes over to the back of the pin, but who cares? Like that, and then we've got another line coming in from there. So we look at the bottom of the board, and we flip over to blue, and I go to layer 1, and we trace that one out. That. Good. Those aren't connecting for some reason, so go back to the top layer and make sure that they look like a chip, at least just a little bit, so I don't get confused later. Top pin goes up to there. That would be every connection. Nope, but that one. Blue, like that. And then on the top layer, oh, geez, oh, I put it on the wrong layer. Boop, boop, boop. And then, ooh, I almost smacked my glass off of the table. That would have been a, you know, spill is one thing, but smashing your glasses all over the place is another. Okay, and then a red line on that. And that's one pin of the thing. Whew. Okay, so that's that chip. It's very quickly done. What about down here on the left? So only the one that goes to there. This one is floating. Oh, but I've been doing this on the wrong layer. Dun, dun, dun. At least I caught it early. Like that, like this. Sure up this one a little bit. There we go. It's fast and loose. I mean, we're doing notations. We're not doing too many fancy things. If I did want this to be a better drawing, I guess I could have done a third layer with the chips on it. And then I could note down, because they're surface mount, it's easy. I could have just noted down what the values of all the components are as I went. But the values of the components aren't going to be all that important, and I can just get them later. As long as I have this master image that I'm creating right here, I can go back to my notes and figure out what's going on. So, 072, let us destroy you and everything you represent, and we will recreate you in the glory of MS Paint. But for now, you must die. And then select none, and then shore up the borders. Yoink. As some kind of a political move in order to garner support out of nothing. There we go. It's a non-issue, but I fixed it. And then we erase this right here. Make that a little nicer. Okay, so what's under the TL072? It's not going to be all that complicated, but pulling it will help us answer these questions. Why did that get all out of focus? Weird. TL072, and we're right up here in the corner. Nobody puts bother in the corner. We put that one back on, did we? Yes, we did. That's what I just did. Oh, no, we didn't put it back on. It's just sitting there. Let's put this one back. It's like, just there. It's just there. It looked so natural in that habitat. and push down on the chip. Wait a minute. No, we checked. This is the right direction, right? Before I move on, let me just look at my reference here. Okay, that is the right way. It only could go in two ways. I don't want to get it wrong. So our chip is currently, 2 pins of the chip are currently soldered. The rest of them are just sitting. Is that the correct chip? Yeah, it is. And so you can't even see. Like, look, it looks like it's soldered, right? But it's not. It's just resting on top of the pads. That really looks like it's soldered. I know it's not because I only soldered 2 of them. Why does it look so well seated? This is the problem with optics and vision like this, is that you can fool yourself into a sense of false security. You could go get a cup of coffee and forget that you were in the middle of soldering something, and it looks like it's soldered. And a good way to avoid that is to desolder all of the pins, to use solder braid in order to rid this of all of its, all the solder that's on the pads, the bubbles of solder that are on the pads. And then it won't look like you've already gone through with an iron. But what I'm doing is fast and loose with the rules. So, and that's a lot of trouble to go through. It'd be a lot of desoldering braid for not a lot of advantage. So what I'm doing is soldering the 2 corners, and then if I heat up the whole thing, hopefully those 2 corners will kind of spring things down. But I don't know if that's exactly happening here. I may have to bop it on the head in order to push it down into the board a little bit. Force the issue. Force the issue. That really does not look different from what it was before, huh? The problem is hot air can damage the FR4. You can start to bubble the circuit board if you're not really careful with it. I guess that's soldered. Now it's off by just like a 1/10 of a millimeter, but I'm not going to touch it beyond this. That's soldered. That's in there. Who knows if the actual chip is functional or not? Because we might have blown up a couple of them by over something-ing them. Just because we swapped in the chip, but the circumstances that might have broken the previous one are probably still there. And I know nothing of the... Hold on. And I know nothing of the voltages that I would probe in order to figure out what the functional status of this thing is. We'll see how similar this thing is to an actual TB303. I remembered the part number. TB instead of MC. MC would be the drum machine, which this is not. And the drum machine, wow, that really desoldered quick. The drum machine samples other drum machines, other Roland drum machines. Craziness. Okay, so not a lot was going on under that one. But we'll mark it down. So, right layer, right color, good. Down, avoid the via, and out. Well, mine looks a little different from what's actually there. Hold on, let's do like that. And then, it is this one. So this via goes around and down to here. This goes up and over. And that probably could have been ascertained experimentally with a multimeter in very little time, because we would have gone over here. Oh, Jesus Christ. This thing takes a journey. It goes all the way to the pin header, where we could have hooked up the multimeter and then discovered that there were very low ohms. So all that effort just to figure out that. Now we know it very precisely, though. We know exactly what's under that. There's one more 8-pin chip. There's 2 more 8-pin chips for us to rip up. I mean, that we have to rip up. We have to. Oops, this one. And then put it back. Oh yeah, we'll solder it first. This seems to be the better method. Where are we? Here we are. are we here? Are we unique? Are we some kind of... All right, let's do this. Then I'll push down on the chip and solder the other one. Okay. Now for the hot air. Oh, jeez. I'm being very careful to avoid touching anything near the circuit board, because after the hot air stuff, the circuit board itself is going to be at screaming hot temperatures, which is why soldering things back in is so easy to do. Give it a little bop on the head. That didn't move at all. Huh. Just make sure that those are soldered. I trust the iron more than I do the hot air gun. Yep, those are all good. Okay. Two more to go. This is the next one. Right here. I don't know what this one is. 62, 530, something or other. Did we mess with this one? I don't remember this at all. Oh, there it is. Is it a, wait, what is this? Is it a 70 TLS72? Oh, 72C, yeah, TLS72. Okay, so let's get this ready. Begone, circuit elements. Okay, so now whatever the heck's going on underneath this thing, we're about to find out through destructive means. Hot, hot heat. Sneak up the temperature. Owie, it's hurting my hand. Get it from this side a little bit. Of course, the tweezers are going to block a little bit of the heat, but eventually it all gets up to temp. I didn't see movement on that one pin. And more temperature over here. There we go. Bada bing. Okay, so now I'll flip it around so we're at the right orientation so we can tell what goes where. Grab this guy and move it out a little bit. All right, nice and simple. So we've got the via that's way off from where it actually is. We've got a ground down there, but it looks like there's three. Yeah, 1, 2, 3. There we go. 1, 2, 3. And then this one goes to that bottom pin. We're on the right layer. Everything's good there, like that. Where's this coming from? Oh, I don't think that's a ground. I think that's just dirt. Let's get rid of it for now. It does kind of look like a via, but I guess it's dirt. And then, let's see, so big guy over there, this one over there, that goes there, and then this goes to that. So this layer, red, like, Oh, that's the eraser. Whoops. What does the top one do? Oh, I see it. Okay, yeah, I see it now. Donk. Donk. I guess that's the decoupling stuff. Okay. How's that look? Boy, there wasn't a lot going on underneath this thing. Looks like these two are connected. Those two are connected. That one goes in there. Yeah. The red line is routed wrong. Boop, boop, boop. Top over to the via. Those two together. That one goes there. Big guy coming from by the capacitor. Yeah, goes to the bottom pin. I got it, I got it. Oops. Let me cook. Mistakes are going to be much weirder on this, though, so good on correcting it. Okay, so boop, boop, boop. 1, 2, 3. Everybody else is happy. And I'm finally happy. Cool. All right. That's that one. Next is the power supply chip all the way up here. We can figure out exactly what kind of goings on is under there. Let's put this one back first. Where did it go? Right there. So heat it up. Plop the ham. Crap. I'm all thumbs right now. I'm gonna let that cool a little bit so I can get my tweezers out of there. The tweezers were sticking, so it wasn't helping me out. This SO8 stuff, hot air is like a superpower. It really simplifies this stuff. You guys might not have seen it, but the chip just shifted into position. Okay. That one's back. Now we go all the way up to the top of the board. For this guy. I need to find a different pad for my CAD software. I need to find a larger pad in Fusion 360 because the ones I have are incredibly precise. They don't give you anything to solder on the outside. These are nice and generous. You can hit those pads nicely with solder. They seem hand solderable instead of machine solderable, although hot air helps, but all right, so now the PSU chip has to come with me. I wonder if this might be one of the things that's broken on the board, having gotten reverse current pretty strongly from 12 volts. When you plug it in, I guess we should see what voltage does actually go where. Some of the biases. Wiggle? Nope, not yet. All right, be patient. Patient, patient, patient. And I'm slowly lowering the heat, lowering the hot air gun, and what that does is raises the heat. Well, that's a very awkward looking set of traces. Very awkward looking. Although that's what we found in the data sheet for the thing, is that those are all outputs. So I'm going to get rid of these labels, and we'll remake them. Well, we'll figure it out in the when we put it on paper. So it's just boop, boop. And then that comes down and does that. And I'll put kind of like pseudo dots on those so that they're known to be connecting. This is a now very known, we can see it much more clearly, and we now know that this does that. Exactly what I thought it would do. Exactly what I thought it would do. And I'm going to wager that that is in fact how that connects, because I mean, how else would you do it? So, and that does it. We know everything that's under the chips now. We know precisely what is connected where. And we can start in on the rest of this thing once I put this back to the way it was. We don't really have many good ways to test, to test these different circuit elements. We did it. Owie, I'm burning my finger for some reason. The finger on my left hand, my pinky finger. I guess that's where all the hot air is like headed to. Come on, buddy. Come on, buddy. Find a buddy. And no. Heat. This solder doesn't really show you that it's molten very well. I don't really know when I've heated it properly. With the more lead-y ones, they get very shiny. And then that's solidified almost immediately. For some reason, I read Bovinet as Bolvar's dad. I don't know if Bolvar's dad is still around. Well, I think that's back in, but I'm gonna soldering iron this one a little bit. It's leaning all the way to the side. I don't remember what streamer Bolvar's dad was from. I'm wondering when Milton is going to come back to streaming. I thought he was, but I don't know. I don't know what his plans are. I heard he was thinking about coming back for that recent UFO news, because apparently there was like big reveal, something UFO something, and it's really just like, I don't know. We got a lot of sensors on planes, and they're a little jumpy. It's not really evidence of life beyond our galaxy, so, or even our planet. There was a good one that they were freaking out about over there that was literally just a cluster of weather satellites, because they do things like that. They have clusters of satellites that go around. So you'll see 3 dots in the sky, and it's like, oh my God, it's the aliens. It's like, no. Spend 5 minutes and start looking things up on the internet a little bit there. Because if something goes around the planet in a particular way at a certain speed, it's not UFOs immediately. We have things orbiting the Earth that create light of their own and reflect light from from the sun. I know it's not fun, but you have to be a super skeptic with these things, because otherwise people freak out. Well, I mean, as you know, the engineer is of course expected to be a super duper duper skeptic about everything, but I mean, most of the time you can find reasonable reasons for the reasonable reasons. Okay, jump to a conclusion. Why? Don't mind if I do. Okay, so we figured out what all these chippy thingies are. Ow, 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 fuck, ow, fuck, ah, ooh, ee. It's actually not that hot. It's not really that hot. I don't fake any of my reactions on here, so you'll never see me shock myself and go, oh no, and all that stupid shit. We need to figure out what's under the big caps, and we need to figure out what's under the potentiometers. I am not desoldering those. We will just figure it out. We have brains. We have brains, and we can use them for pattern recognition. Actually, they found out that people who recognize patterns more easily struggle with other kinds of brainy sort of operations. It's like a trade-off. We have brains. They're there. They're wasting resources, but they're there. So what we can do is I can ohm it from one exposed piece to another exposed piece, and I can figure out whether or not there's a connection there. Easy peasy, lemon squeezy, breezy. Easy squeezy, lawsuit breezy. I squeezed the wrong thing. Let's go to this right here. That's right there. I guess I can't have it all. I can't put the... Yes, I can. I can have it all. I can have everything. This is my show, after all. It's mine. I can have everything I want. All of the cameras! There we go. Okay, cool. That's every camera, except for BTS. BTS is not on the screen right now. So what I'm gonna do, I gibber very quickly when I start really getting into what I'm doing, so I'm sorry if I'm leaving people behind in my reasoning and stuff, but yeah, I tend to talk really, really fast, which I shouldn't do. Where's the, oh yeah, the multimeter needs to be on here, not just that. We need to see the multimeter. But I can't get my hands in here now. Maybe this goes there. Maybe that'll work. Perhaps. And we need to be able to see what I'm connecting to. So I'm connecting to, oh God, it's all the way over there. There we go. So from the upper left, going to here. And then we're going to 1, 2, 3, 4, 5, 6. I can't see what I'm doing. This looks squished for some reason. Is it? No, it's not that one. It's this one. Nothing? Perhaps I've misjudged you. Wait a minute. We are going to, yeah, it is this one. Huh, plot thickens, I guess. So, not there. What about this side of the cap? No, what about the other side of the cap? Really, nothing? Can't really, I'm not as nimble as I could be. Well, let's check out this one to this one right here. Okay, so that one is below 1 ohm. Oh, I don't want to hurt it. I don't want to scrape anything up by accident. Okay, that's enough for me. 2 ohms, 1 ohm. My fingertips are buzzing because of neuropathy. Fun times. Glucose level's fine. It's just something that comes up every now and then. This, usually I hit the gym when that happens. So that does connect there. It's just my capacitor symbol is like right in the way. Ah! There, good enough. And then my cap needs to be actually connected. I kind of went through here quickly, like that. And then under the board, there's nothing else going on with this cap. So where does this cap go? It's likely that it goes down here and over to this pin, although we don't, well, okay, so the underside of the board does indicate that. So let's check that out. Let's go from here. The probes are very long and I can be agile with the leads here. So like that. And then we're going to this one, 0.7. Okay, so that is what happens. So this one just goes right meow to the cap. Cool. So that's one capacitor that we figured out what is going on underneath. And yeah, that one is not connected over there. I tested that one. So cool. Okay, next we have, nope, nothing there. There's a lot of them though. There's a lot of places where I'm not quite sure about what's going on underneath things. And having done what we just did with removing all the stuff, we did clear up a lot of it. So we're going over here and we're just double checking that that doesn't appear to, it seems that that one goes straight down. .7, and then if I test over here, 400 ohms. 400 is rather low, so I don't know if maybe the bias is triggered by it, but those are grounds. So that would mean that that one is not connected to anything. It might be another diode. So I was wrong. Dun, dun, dun. How could I have been so naive? Was Earth all along? Yes, you finally made a monkey out of me. Yoink, yoink. I was on Twitter the other day and I had to listen to the whole thing. Dr. Zayas, Dr. Zayas. Now, there's nothing going on underneath. It's in a totally blank area. So I guess it's some kind of a diode. Unless this is one of the oscillating unless we're making noise. If you're making noise, you can use the leakage of the junction of the transistor in order to create a pretty good amount of white noise. And we saw that on the Erica Synths module. But I don't think the TB303 has any business creating noise. I'm not certain about that. I haven't had seat time with the TB303 schematic. I need to find, if anybody knows like a good creator that's done sort of a ride-along of what's going on the TB303, I don't see why nobody would have done that by now, but if nobody has, that's fine. But if somebody has done like sort of a rundown of that, because I know Erica has done a lot of circuits that are very similar to the 909s and the drum machines and stuff like that. Erica Synth's YouTube channel is a brilliant resource. It's really cool to be able to follow along with what they're doing and how they are performing these functions in these different devices, and what the decisions were in order to put certain circuit elements where. It's something that's absolutely magical to be able to have access to. Okay, so that one's fine. Whoa. We know it's under there. We don't precisely know it's under a lot of these, but they're very they're sort of self-reporting. You kind of know. There's one that we don't know though. So we have two leads. One of them's going all the way over to there, all the way over to there, all the way to some 072s. And so, oh, that should have a lump on it. That. I wanted to work on this today. I'm sorry if you guys were excited about the big book of circuits. The big effing book of circuits will come out another day, and we'll do something to sort of build our confidence, because the last couple times I've tried to make just a simple oscillator, I have been made a fool of by this stupid book. A lot of okay, time before the last, we tried to make a very simple circuit that would oscillate, and it turns out the cool noise maker required a whole lot of extra circuitry in order to make cool noises. 1001 circuits. It's the circuit reference book, I guess. I forget what the title is too, and it's sitting right behind me. I'm sitting on it right now so that I'm tall enough to stream. But we tried a while ago to build one of the circuits, and it turns out it needed all of this supplemental, that does connect, all this supplemental stuff in order to get it to function. It was like one little like amplification circuit on the end, and so the circuit reference book went, this is a cool noisemaker. And it's like, no, it's not. It's not creating a cool noise. An uneven amount of inverting Schmidt triggers, wouldn't that create like a close to a square wave, or like something just off a square wave if you filtered it? I don't think that's what this is doing. I think this is using the matched RF transistors in order to create a sine wave that it can then, you know, be a VCO with. All right, so we got that one there. We know what's going on under it. We know where that's connecting. We know where that's connecting. We know that that connects right there because it's all right in front of us. These connect to ground because there's vias locally for each individual one. We have this one that is pretty definitive because you can see the trace underneath it. And then the other side of the capacitor goes to all this stuff laid bare out and around it. These capacitors block a lot of what's going on underneath, and so we can't exactly see what's going on. But there is a local via to ground next to both of the ones that are ground. So ground here, this is the 47 oof microfarad, the 47 microfarad to -12. So this is -12, and then this is ground, this is ground, this one is +12. What's going on right here? What the heck is that? That may be going up here, and so we'll go all the way up here to, yeah, V+. So V goes like this. Oh, that's so confusing. I'm gonna go around this like that and just do that. That makes sense, and we can logically figure out what exactly the PCB traces are doing here. Because if we look at the bottom layer, there's just a via hanging out right there. So we eliminate everything else, and we know that that's what that's doing. And also, this is a common structure in synthesizers. When you're power first comes in, you put a 47 oof capacitor on it, just in case things get a little squirrely when you're plugging it in. Although, you know, if you're putting capacitors on it, why didn't you put diodes on it? Please answer me this question. Acid Labs, why did you do this? I'm considering whether or not I want to gift Dave a couple of Schottky diodes just to keep his circuit from blowing up the next time he decides to accidentally plug it in while on opium or something. I don't know what the hell he's doing over there, why everybody's plugging things in wrong. It is actually ridiculously easy to plug this thing in wrong, though. So as much as I want to just say weird crass stuff, it's not really his fault, to be honest. You can blame the users until you're blue in the face, but what the hell is going on right here? Let's delete all this and start over. Dr. Zayas, Dr. Zayas. Oh, Dr. Zayas. Dr. Zayas, Dr. Zayas. Can I play the piano anymore? Well, of course you can. Well, I couldn't before. It's in my brain, I'm sorry. Take this, like this. Let's put a capacitor right here. This, a little bit of this, a little bit of this right here. And then we got to figure out what in the heck's going on underneath this. Make keyed connectors. I have a box full of keyed connectors. I was telling Dave, like, I could desolder the connector and put a keyed one on. It's not like they didn't have room on this thing too. Acid Labs just decided not to put any extra effort into PR. It's almost as if they wanted you to break this. I think it's more the German attitude of like, that is impossible, it is illegal. Like, it's one of those things where they go, it is not possible that the user would plug this in wrong. We gave them instructions on our website, right? Like, they just don't think about stuff on that level. That is impossible. We sell to people who would not make that mistake. That's it. That's just the end of the discussion. Whoa, that was the eraser. Like that. Okay, so let's figure out what the connections are down here. Also, why is that red? Oh, that's under the board. Oh. Well, do we want to correct that, or do I just leave it in because it's going to take us time to correct? Some of these turned out to be turned out on the wrong layer. I'll just leave it alone, I guess. But this is a trace that goes under the board. It goes up that way. I gotta correct it. I gotta correct it. I can't leave it alone. Easy to draw anyway. Eraser. Let's make that a slightly larger eraser. And then you... Oh no, that was the wrong one. I blamed the wrong thing. Wait, that one goes on the top of the board, but what's that one doing? What the heck? Oh, they are doing the lawn stuff here. Oh, that one doesn't go there at all. Or no, that one's on the top of the PCB. But then what's this one doing? This one is supposedly connecting down there, but I don't think that's correct. Oh yeah, and this is the leftover line on the PCB picture that I accidentally put in. No, it's not really no, the kids are wrong. It's that they would never consider that somebody could plug it in wrong because you're not supposed to plug it in wrong. That's sort of the attitude. It's just this like block in the German brain. They just would never think that somebody could do something incorrectly. Let's go here and do a little correction of this stuff. This is a very sloppy drawing. The whole purpose of this exercise is to get comfortable with things that are a little bit janky. Not everything is perfect here, and we revel in that. This trace is not even on the thing, and I can't erase it unless I do something like this, here, eyedropper. Where's my eyedropper? Right there. And then just like paste over it. So it doesn't catch my attention. Oh boy, we're editing reality. I'm gonna hit save. Yeah, I was working on this late last night. And so I did some regrettable things with the traces. All right, so this is on the blue layer, and we go to the blue layer, and now we mark this, and we go down this way, and we can just go right under stuff. That's okay, and we'll correct this whole area because it's a little bit of a mess. This we'll have to erase later. That goes here. And so we go back to the red layer, and I take the eraser, and I just have to carefully go through and remove this. The reason I'm doing this is because layers are going to cross over each other pretty blatantly, and it gets confusing. Dr. Zayas? Dr. Zayas, Dr. Zayas. Okay, so any others that shouldn't be on the red layer? There's probably tons. Like this big blotch of blue should not be here. And then we do our blotch of red using the color history. So when that's there, oh, that's, oh, whoa, whoa, whoa. Okay, hold on. Erase all of this. Red, go like this. This is just like an orphaned via. Oh, or it's not. It might actually be connected to something and I just don't know. And then that blue is there. Okay, we got that. But then we don't know what that's connected to on the top layer. It looks as though it is connected to that resistor. Where does it go to? It goes to the IC. So let's just check that one quickly before we come back over to here. There's so much correction that I have to do for mistakes that I made earlier. I have to pay for my mistakes. So we're going up there. What did I say? What did I say? What? Be making an IC joke with the IC. That would be this one here. I'm trying to see if it's going to that via. And these vias are not as easy to poke in on. But what this does is it goes up and it goes to here. And it goes to here. Okay, it does. Good. So that one connects directly up. So we'll do red, correct layer, and just do that. Okay, that's a little confusing, but it's just because of the parallax between the two layers that things are off. So I tried to kind of line them up, but it's okay if they're a little weird. I'll just hopefully remember that this area is strange. Let's figure out what's going on under this Jim Jam. So under this Jiminy Jam Jubal, oh no, it's this one that we're trying to figure out. Yeah. So we're going down to that. There's some layer jumping here that shouldn't have happened this way, and I don't know what really to do about it. I could come in here and correct it all, but I guess I'm just going to leave it alone because this isn't necessary. This is going to be a document that I save, and this is a reference, but it's not going to be the schematic document in the end. So these weird mistakes that I've made here by not correctly defining the layers and stuff they're not going to go anywhere but to confuse me. That's the only purpose of them. This is to confuse me. Oh God, it goes the whole length of the board. All right, so from all the way over here, we need to figure out if that connects to the outer pin of the capacitor. So outer pin of the capacitor, because it doesn't really look like there's much else going on in this area, all the way over to here. I saw the probes jump a little bit. 250K, so that is not connected. Huh. So how about the other side of the cap? $7M. All right, so what's the next stop for that trace? That is taking a journey all the way up to there. Okay. So we're going all the way to here from all the way down here. That's still 250K. So how about from there to the outside of the cap? That is connected. It's 0.7 ohms. So what's happening under here is that this is going to this side of the cap. Correct layer. Is that really the case? That's so strange. Oh, this is confusing right here. Hold on, I need to clean that up. How are you being done? Is this going down here? No, but we already tested that. It's not. Is that trace of this down here, this resistor all the way on the other side of the board, all the way over here? That's my test point here. And then we go all the way over to the capacitor that we're looking at. And I check here. No. So where is this trace going? Because it doesn't appear to be going here. What the hell? It's going to this one? It seems to be passing through and not connecting to anything, even though the trace goes all the way to there, and then it dips under this thing. Is it going to this right here? Maybe going to one of these pin headers. An anonymous gifter gave Trump's butt plug a tier 1 sub. I wonder who that could have been. It was a weird one to gift. What is that user even doing on Twitch? What is it all about? You got to sit down at the end of the day and go, what have I accomplished? Can you ohm out through a capacitor? What you'll see is you'll see it charging the capacitor. You'll see it build up, charge, and so your ohms will start climbing and falling in weird ways. And then if you suddenly reverse your leads, it can actually show you negative resistance. Well, yeah, one would hope that at the end of the day you're able to sit down. But other than that, First Amendment rights for usernames, I guess. 23K? Huh. My hands are buzzing. Hold on. Blah, blah, blah. Like a neuropathy, man. It's terrible. Doing stuff like this, I'm doing a lot of claw grips on multimeter leads and stuff like that, and your hands start to buzz. Like nerve ending static electricity. I don't know what or nerve ending, what is it? TV snow, whatever you call that. You down all the way 45 degrees, 45 degrees. And then you sneak under this capacitor, and then you do something else, and I don't know what. If it is going over there, then, I mean, that would make sense. And the way that I'm getting positive on the two things, but then that doesn't make sense for this one coming in here. Hold on, I'm going to delete this all again on the top layer. You're all gone. Start over. So I've got a via right here. That takes me out to this pin. Let's start with this pin. I probably should have the pin header adapter that I have. But 1, 2, 3 would be the fourth. So we go fourth pin on its thing. 1, 2, 3, 4. And is that one going to, well, fourth pin here, all the way out to our resistor that's 1,000 miles away? Yes. Okay, we got somewhere. So that means this is isolated. This is isolated. Okay, all right, so far we know that this trace right here on the top layer comes down, oh, that's not the right tool, down like that. It probably does a little bit fancier stuff, but the entire purpose was to take whatever the heck this is at this junction and put it right here. So it had to go up and around and through and down and around and blah, 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 blah. So is that definitively connecting to pin 1? Actually, that's not necessarily pin 1. We really could have used a silk screen on this Acid Labs. Paid $600 for your synthesizer. You could put a silk screen on the... All right, 2 ohms, so that is connected like that. So this is connected right to there. So this is correct, and we have a capacitor inside of all of this mess. I'll just draw it as small as I can. That goes all the way to there. And we're only left with one circuit junction, but I don't think that's going to ohm out. So we go all the way up to here. This resistor right here. Where is that going? That goes under our capacitor, and then what? So let's test it. So we go all the way over to here, all the way in no man's land, all the way here. Just went, just barking at the people doing the lawns today. I guess they're a day behind. Here would be the reasonable, oh, it is connected there. I guess when I did it before, I didn't do it. Something must have slipped. So yeah, cool. All right. I know this is hard to see without light, but the lights just turn on and off on their own. So, okay, so that goes to the negative lead of the cap. There we go. So we're doing some kind of a DC cut there, probably with an input signal. All right. Cool. That was an area that kind of vexed me a little bit. I didn't quite know what the heck was going on. This is really sloppy, but I know what's going on. Any other unknowns, or are we at that stage? This is where I would go get a cup of coffee, let my brain take a break. We're not robots after all, although people would like to treat their staff like robots. When I was doing this professionally, everything was under a time crunch. But you go get a cup of coffee, talk to a coworker for a minute or two, and just give your brain a break before you come back and hit it again with all of your concentration. What are these things? We need to figure out what these are. These are SOT. No, that's a different package. What is that package? SMD packages. Be careful not to look up like GIMP packages and stuff on the internet. Even though you might be looking for an image editing software suite update, don't Google these. Don't make the mistakes that I've made. All right, so we're looking for SMD packages. We look for the filthiest thing we can possibly find. So there's a classification of 6-lead package that might not be included in some of these things because the market is always evolving, right? There are not as many standards. You know, nobody sat down and said, these are the exact parts we're going to build everything out of from now on. There is a degree of standardization. People expect you to be putting things down on a flat circuit board, for instance. The assumptions that can be made from device to device. But again, there's no specific committee that's making all these decisions. There are lots of committees making decisions. But yeah, again, the requirements of what is needed for particular devices varies. And so surface mount parts are created with a huge amount of variation between them. And so finding the specific package, it should fall within a category if they want to, for instance, actually sell their product to human beings. But sometimes things don't. In our case, we have this weirdo looking 6-pin thing. Weirdo looking 6-pin little jobby, and it might stand to reason that it is a diode. I am under the impression that this is a, where is it? Where is it on this? Okay, there they are. I'm under the impression that this is a diode ladder. This looks like an SOT 223-6, but an SOT 223-6 might be way too big. 2.0 by 1.5 by 0.95 millimeter. So I'm going to need a pair of calipers. Calipers are actually very good. Oh, that's a very good... calipers are very useful in electronics because they sometimes will give you a package designation name and then they give you some dimensions to it. So you'll find yourself having to hump the calipers a little bit and become a mechanical engineer. Electrical and mechanical engineering are very similar. We live in a digital world. I'm just a digital girl. So what are the dimensions on this thing? 2.1 by, I can't get this thing in here. 2.1, 1.2. 2.1, 1.2. Well, oh, Jesus, that's the wrong. 2.1, 1.2. So I guess we are an SOT 363. 2.0, 1.25, and then 0.95 height. I can't really get in there and measure that. Yeah, this is a decent one. This is NXP. NXP does good stuff. I mean, NXP keeps me alive, to be honest. they're my insulin pump chip. That's the microcontroller that runs my pump. So I am alive thanks to NXP to a degree. You know, I would obviously be able to survive without it. So SOT23 is typically the reference, but that's 3 millimeters width on that thing. So we are we're a little bit more esoteric. We're a slightly smaller 6-pin device. An SOT 457, perhaps? No, that's 2.9. Yeah, we're definitely 363, SOT 363. So the package is very important in identifying what we're looking at because we don't exactly have a part number on parts this small. We can just get an impression of how it functions, and we can look up parts that do what it do. And that will help us get an idea of what's out there. And again, this is where reverse engineering sort of rests. It sort of leans on your experience, the experiential element of this. However, from my impressions, from my experience, it seems as though Acid Labs was like, we should put a diode ladder in here. What diodes can we use? And it might be that there was an old school diode in a can or an old school diode in a 3-pin D-shaped package. Why would you put these in here unless you have a particular diode in mind? And they may have found an equivalent diode with that. Although this could be, obviously a dual diode, right? It's a package that contains 2 different devices. Is it a transistor? Well, we have 4 leads connected to this thing, and we don't know what's going on under the chip. I don't really want to remove one. These are a specialty part. So this is a very special thing right here. We know that a diode ladder filter from Hajiwo, at least, we are familiar. What's going on with the camera work? I keep clicking on the wrong stuff because I'm thinking about what I'm saying to you guys. I'm actually concentrating on what we're doing because, again, this has been months in the making. All of this knowledge that we have from trying to build the Hajiwo circuits unsuccessfully, trying to build the Hajiwo circuits and building all of these different synthesizer modules has led to this. So I've actually got a little bit of knowledge in what I'm talking about now. And it's fun to be able to do this with you guys because I get to flex a little bit. So diode ladder filter, diode larder filter. The hovercrafts are going to be descending upon us soon. This is a really good video from Moritz Klein. I said Erica Synths earlier. Moritz Klein works with Erica Synths. Moritz Klein's YouTube channel is amazing, but the problem is this one actually just stirs my brain around, and I'm unable to recognize anything that's being said. Give me 1 sec while these guys pass over the area. Bees. There's bees everywhere. Now it's weed whackers. Ah! I should just lock those out. Okay, let's look at schematics. Looking at schematics will give us an impression of what goes into something like this. You would have 2 diodes and a capacitor between them. So something like 4 capacitors and 6 diodes. 1, a 2, a 3, a 4. Although that value of capacitor is much different from the others. But then we have 1, 2, 3, 4, 5, 6. I'm thinking diode ladder filter. I think that's exactly what's going on here. We have our transconductance amplifier. We have a diode ladder filter. And then there are various, there's op amps nearby. Let's look at a couple different circuits here and see if we can find a common element that might help unify us. Well, this one has a balanced pair of transistors on it, and then it has a transistor ladder filter. What does the M303 or the TB303 have? bees! I should make a module that's just bees exclamation point, and it makes all kinds of noise like this. Oh god, I'm breathing in two-stroke fuel. I'm really sacrificing for my art here. And then there was that stream where Bother got, like, exhaust poisoning. Didn't we have a full schematic of the TB303 up earlier? That one's fine, that one's fine. This one can close. That one can close. That one can go away. Why do these keep being blank? Stop being blank. This one is the... Oh, this one's the transistor guy. This one we don't need. That's our LM317, our voltage regulator, with almost the exact circuit that's in there. Quad single pole throw analog switch, but then that's the TB303. Okay, so this one stays up. Find the drawing of it. There we go. Leave that up like that, because then when I go through, I'll be okay. That's that chip. That's this chip. That's that chip. But then this, for some reason, this PDF client always goes to a blank page. I think it unloads some of it or something, because I had it here. I clicked over and back, and then it's gone. This is so stupid. Sucks. All right, let's see. I mean, really, I should be like downloading the PDFs and viewing them that way. Okay, so here's our TB303 and the block diagram of the TB303, which is something that we might want to pay attention to in the near future to try to figure out what blocks we're going to reverse engineer at a time. I come down here, we got the main board, tempo control, MIDI input, that's all digitally kind of stuff. There's one of the Schmidt triggers right there with a couple diodes on it. Come down here, and here's some of the meat. Power supply, voltage controlled amplifier, voltage controlled filter, and then in the voltage controlled filter we have a transistor ladder filter. And are they replacing that with the diode ladder filter, because we've got the transistors connected like that? Well, we also have transistors connected like that in the transistor chip thingy, where they're connecting, because remember I noted that the bases were connected to the collectors. So what filter do we have? Are these dual transistors in this location, in the little ladder area? Oh, how do we find out? Well, okay, plan B, or D, or C, or whatever the hell we're on, these have markings on them. There is a surface mount. See, these are really accurate. These are like really fragile capacitors. These look like multi-layer plastic capacitors. So they're really accurate. They're really fragile. You can probably solder them in, and that's it. Base times base times base. Yeah, I don't know. There's a lot of matched pairs in this too. Look at this. 1, 2, 3 matched pairs, which if we look at the one that keeps blanking me out, stupid thing, stop blanking me out. Where is my stuff? It's like unloading the part of the PDF that I need. There it is. That's not 3 matched pairs. But there are 3 of those little chips. There's 3 of them. I wonder if those are the matched pairs transistors. Okay, well, this is getting crazy, but we'll try looking up the part number now. So 1F, and then is that a T? I think it's a T, period. What up, Celia? 1FT SOT363. Amazon. 45 volt, 100 milliamp transistor. BC, so British, BC 847 bullshit. BS, 1FT, Nexperia, dual NPN, current part, bipolar transistor array, dual NPN, 45 volt, 100 milliamp. Celebration of Constitution Day. Ah, cool. I don't know those Norwegian holidays. Norge days. Data sheet right here. And it may be that we found it pretty definitively. I mean, there it is. So that means our 3 matched pairs directly out of the data sheet for the 303 is realized in these little parts right here. And I guess what you could do alternatively is you could take transistors, and again, the base and the collector of the regular old. So I could take 3904s and put those in here because they have similar specs. They decided to do supermatched transistor pairs. If you were to use loose transistors to do this, you'd have to have a transistor tester, and you would match them that way. You'd figure out exactly how they're matched. Or you could use a supermatched transistor pair, but those are like $15 to $40 each because those parts aren't really sold anymore. So instead, they decided to use this more modern Nexperia part, which is kind of pretty interesting. I find that very interesting. But then how, I guess those would be connected internally to each other, huh? Thinking noise. I need to have like voice and noise activated stuff that comes up on screen so things can be a little bit more flashy and crazy. Old Imgur? Old Imgur? I call it Imgur. Just like I call it a GIF. Look at all them people. That's pretty cool. I'm choking on 2-stroke fumes right now. They're doing the mowing and stuff out there. So it's like one of the city celebrations where all the school kids walk like a train. No military parade or anything that other countries do. The day is more focused for kids and ice cream. Can you believe that like Trump wanted to have like Kremlin style parades in America? Like so many things about that are so wrong. So wrong, so wrong. I'm glad you guys don't have a big military parade in your country because they're so cringy. They're so stupid. It's just so that the big leader can go, look at my toys. Ha ha ha. Yeah. It's the worst thing I've ever seen. It's supposed to instill a sense of national pride. No. No, it ain't do that. Okay, so we have a dual transistor here, so that simplifies things quite a bit. BC847BS. So we're going to mark this BS down. Where can I fit the text? We'll put it up here. BC847BS. And it is, in fact, a transistor. They're not doing a diode ladder. They're doing a transistor ladder, which I guess boils down to the same thing in the end. Because, I mean, the transistor is essentially 2 diodes. But, huh. I have Dr. Pepper today, which is probably why I'm gibbering, because it's got a lot of caffeine in it. We got 2 taps coming from the transistor ladder that are going into our mystery chip. So all of this is in service of figuring out what our mystery chip is. And so what is the transistor ladder interacting with? Remember, Acid Labs based this thing off of the... Wait a minute! What is going on here? Violation! So we got that one rolling through there. We have that one rolling through there. We have a dot here. We have a trace here that goes into question markville. We got to figure out what's going on here. Violation. I also don't have a plus sign on the front of that thing. So boop, boop. All right, let's figure out what's going on with this capacitor, and then we're going to try to figure out what this mystery chip is. We're getting close to figuring it out. I don't know what the rest of the circuit layout is supposed to be precisely, but we have a bunch of connections. We don't know what's where. I'm going to guess that this pin here goes to that capacitor, and then this goes down and over, and then this just goes down and under, because we already know what's under the chip, because we took them all out. We also don't know what's going on with some of the pins of these guys. They all look like they're connected in the same way, but I have a feeling like those are connected, and maybe like there's something going on underneath these chips, and we'll figure that out in just a minute too. So let's get the multimeter out, and let's start ohming it. Wow, that resistor did not go back very smoothly, did it? So are we from here to here? In fact, we are. And then this one, I'm going to try to poke in on the via, like from the side like that, and see if that'll make a connection. No, they got a good silk screen on this. They got a pretty thick silk screen. Are we connected to either of these? No, how about you? HBU. Nope. But this one to this one? That is correct. Actually, 80 ohms. Wait, 80 kilo ohms. 80 kilo ohms. Kilo ohms. Well, that's not connected. What the heck's going on here then? If I'm here and not here. Or how about if I'm here and here? No. Here. No. Some fishy's going on underneath this thing. This is coming up and over, and then we've got, wait, where is this? Where is this picture that I'm looking at? We've got our orphaned via. We've got, wait, 6 to 14. You go up to 14 in that country? We go up to 12, then it's college. Sorry, I'm trying to mess with this circuit, so I'm like really into this right now. Oh yeah, you guys are getting those hot days. We've had a very cool summer so far, which I am all here for. All of the newscasters, it really concerns me because all the newscasters are like, oh boy, it's gonna be warm out, and it's like, guys, it's like 80 degrees, and winter was yesterday. Like, they're like, wow, 80-degree weather this early in the season. This is great. I'm gonna go to the beach, and I'm like, the planet is dying. Can we acknowledge that the planet is dying, or are you guys gonna get fired? Like. Utterly ridiculous. Just psychotic behavior. There is another trace that comes into here with a via, and that one is coming from up here. So this up here, the 4700? Yeah, the 4700. The bottom of the 4700 comes in under the capacitor. I hate seeing the sun. Pretty nice to sit outside and eat barbecue. I don't know how barbecue food is not winter food. I guess because you cook it outside for a long time, but it's so heavy. It's definitely like rib sticking kind of stuff though. Like you don't want to have that in the summer. Like, wow, it's so hot out. I'm going to eat barbecue and then feel like I want to die. Redirect all the blood in my body to my stomach. I'm going to have to pull this capacitor. I really don't want to pull the capacitor. 80 ohms. I keep getting 80 ohms everywhere. Is there something wrong with my probes? Check the probes. No, the probes are fine. Heavy, but it was good. So we opened up like a 20-pound, I think. No, it was more like 10. It was a big piece of pork shoulder that I was going to spend the day smoking. And we opened it up, and apparently there was a typo in the goodbye date, and it was stinky pork. It was so disappointing. I was supposed to have a ton of pulled pork on my hands right now, but nope. What's going on here? How is this all so difficult to probe? We know that this connects there, and it goes under the cap. But when it goes under the cap, we don't know where it goes from there. we know where it goes from here, because from there I can trace it up to this test point here. Maybe that's what I did wrong. So from this test point here, we should know that goes there. Fuck. That goes here. Okay, so we know that. So this comes in and it doesn't touch the cap. And then we have two leads going there and there. So it's stand to reason that this lead goes to this. There we go. Okay, so maybe I wasn't getting good contact. All right, so it's simpler than I thought it was. Where's the cap that we were looking at? Okay, yeah, so that's how it is connected, and this does not do that. Instead, oh, and there's a via down there. So what's going on there? So this goes across like that, and then this one, we did test this. So this goes to the via and then over to the 4700. And let's check that by looking at this leg of the transistor. Oh, we don't have to change cameras for that. We don't have to change cameras for that. So, oh my God, where were we? We were right here. Oh yeah, maybe I do need it. So we were here and all the way up here. Okay, cool, we did it. That's how we figure out what's going on underneath these chips without removing them. Barbecue sphere? Oh, you had to reinforce one for a project? That's pretty cool. I've never done a whole pig at once, so I don't have that many people eating. I was gonna cut this piece of pork into two chunks. Freeze one, do it later, but it was just stinky from the get-go. It was unfortunate. Very unfortunate. So that's connected like that. And then this one's connected like this. There we go. Cool. So that was easy. Just what I thought would happen. Where's it? Where's the ladder? There it is. So it's like this. This goes yoink. Oops. This goes yoink. And this one goes yoink. It does that with all of them. There we go. 4 p.m. for dinner today at 3. Yeah, my chips would run out, and apparently, according to my barbecuing friend, soaking them really helps with this. Is not to break the heat, because the smoker that I have has a chip tray at the bottom. You have to open the entire door in order to replace the chips. I should like build in a little door that I can open up so that I can just sneak the chip tray out and put a new one in. Because if I change chips, it breaks the heat and then the temperature falls and you just stop getting temperature into your barbecue piece. I have one of those digital thermometers. I should get the Wi-Fi one, but it's like 115 bucks because they like to extract money from people when you do stuff like this. But the digital thermometer has been kind of amazing because I can see everything that's going on. I can sit down here and have the little extender piece near the window there and the smoker in the alleyway, and then I can watch as the temperature sneaks up over 1 billion hours. But it's pretty cool. So I'm gonna test these to see if these are connected or not. And then we have to get to see our mystery IC to see what's going on with that. So there's that, and it looks like they are going to be connected because of that, because of the transistor that's off to the side. So I'm going to guess that I'm going to get ohms here. Yeah, okay, so that is connected like that. We're getting into the nitty-gritty, the little details here that'll make this a little bit more clear what's going on. Yeah, it's a multi-point wireless one, and I probably shouldn't have bought it, though, because I should have gotten the Wi-Fi one. He booped. Oh, damn it. He booped us. Not necessarily even in the snoot. It wasn't specified. Okay, so what are Chip? What are you? Scratched away Chip. we have the diode ladder of the TB303. We were corrected about that earlier, and I need to make sure to get that right. Oh, I'm sorry. I'll try to remember that, Diano. Continue to correct me. I should be using they for everybody, but you guys can just like bop me on the head every time I get it wrong, and eventually it'll stick. Okay, so we're looking at this part of the circuit because it's a cat, so you can use it. That thing. Okay. This chip has been scratched off. Acid Labs went out of their way to figure out what chip would replace something in the original TB303 so that a modern component could have the same sound as the TB303. FFC has a pronoun badge add-on? I'm not going to go that far. Listen, I'm not anti-pronoun because I'm a citizen of the internet, and on the internet we call people Nyano Cat, right? I'll use whatever you guys want me to refer to you as, but I am not going to install plugins to help me do it. I'm just going to get it wrong and get corrected a lot. That's as far as we need to go. These are interesting components. I've noticed their part numbers on these things are different. They're different. I will never hold animosity towards people correcting me on that kind of stuff as long as you don't against me for getting it wrong. That's the deal. No, that's the one joke. That's that one joke where when you talk to a conservative and they're too dumb to like reason through and they don't have any empathy to think about anybody else's situation, and so they immediately default to start making fun of pronouns, and it's the dumbest thing you've ever heard. Well, they have that attack helicopter thing, and that joke just comes up so much, and it's so tired and stupid. It's like, is it that hard for you to refer to? And with those same people that do that, right? They make that joke, and then they meet your dog, and they go, oh, he's such a nice dog. And you go, well, he's a she. And they go, oh my God, I'm so sorry. I meant to say, I'm so sorry. Your dog's a she. Oh, nice to meet her. Good girl and good boy. They don't somehow connect that with like their empathy towards other people. Yet they feel such remorse for misgendering a dog. It's madness. They're stupid people. They're fundamentally very stupid people. Toaster? I haven't run into Toaster that much. It's just the attack helicopter one is just so dumb. It's so dumb. I will refer to you as an attack helicopter if you want me to, but I know you don't want me to. I know you're being disingenuous. I don't get what's so hard about that. We all have screen names. All right, so what do we have here? Sorry, I'm using that as a springboard because it's something that I'm frustrated with some of my IRL friends. It's something that I've been routinely very frustrated about. So not to single anybody out or anything. All right, so this part of the circuit is madness, but it is reflecting part of the TB303. So let's take a look at the TB303 and see what's going on around that transistor ladder filter. I think it's probably called a transistor ladder filter, although I don't know because I've never seen one before. I've seen a diode ladder filter. What's my motivation? I was already on the right scene and I'm going for this. So we're looking at the TB303, which is the legendary acid house early 90s squeepily sort of blade sounding synthesizer. And Acid Labs has taken the synthesizer part, the sequencer part of the synthesizer out. And so we just have the base audio making stuff. But they ran into the problems that we would have if we were trying to build this today, which is that this is not a product of today. This is a product of like the early 90s when there was a completely different, we have voltage levels and stuff too. Oh, that's going to help us out so much. I love Roland. I love Roland so hard. Look at what they do. They give you voltages and stuff. Oh my God. Oh, look at this. Oh, it's amazing. Yeah, having these little like voltage things in here in order to be able to trace into the circuit and fix things is very, very nice to have. And it would be something that we would absolutely utilize on this synthesizer if it had the same thing. But Acid Labs decided to scratch some of the values off of their various components. According to this circuit, and I don't really know where the ins and outs are coming from because I haven't looked closely into it, we are mostly dealing with transistors. We're not dealing with anything very super duper specific, but we've got 2 transistors and then a capacitor, 2 transistors and a capacitor. And we have 3 balanced pairs. 2 of them are in service of that. And then we also have 1, 2, 3, 4, 5, 6. 6 is not the amount that this chip contains, although I wouldn't put it past them for using multiple of the same chip, and then it would stand to reason that they would also scratch. I'm looking for the chip schematic. It's one of these. It's one of these. Where is that thing? Where is it? Where did it go? Where is this fucking thing? Where is the stupid... Hey, where's my chip? Where's my chip? What have you done with it? There it is. It's the blank one that has to like load in separately. Can I open this in something else? I could print it to a PDF. It's already a PDF. Nope. Download. Security code. Enter the launch code 36342. 2. Now I'm just going to open it in the browser. Now it'll actually load in every time I click on the page. There we go. Okay, so we know that one of these chips is in there, but this thing contains 5 transistors. Would this thing contain 5 transistors? How many pins is this thing? This thing is 14. 1, 2, 3, 4, 5, 6, 7. Yes, this is a 14 pin. And it would look like the video that we had, which is, hold on. This thing. So the text would look like this. JM86A LM304 6M. The JM86A might vary a little bit because it might be a lot number, but then again, these are both off of the same manufacturing run, so. LM360. This one is much better scraped. It's possible. Oh. Is that a 1, 1, 2? I was actually about to. Although not wet. I was just going to try to brush it with my finger oil to see if the oil would open it up a little bit. I'm going to lick my finger, scrape it. This is 1080p. Oh, bother spit. I need that light setup that does that rotating light. I think you might have linked that, where there's one that does the camera in sort of a rotation, and there's one that does the light in a rotation. Let me get my pen light here and just see my pocket pen light. Turn it on the dimmer setting. There's something there. LM? I don't know. It's tough. It's very tough to see. They went deep right here, so that kind of blanks it out. I'll try the wet finger thing again. Freaking German electronic enthusiasts. Why would you censor us from this stuff? Roland has the whole schematic available. Thank you for the follows. Appreciate it, you guys. drop me a follow, a like, a comment, a subscribe, a bell. I don't fucking know. Whatever you guys feel like doing. I was actually getting distracted by these part numbers down here. 3F and 1FW. We'll have to figure out what those are later. But there's not a whole lot going on down here. Backlight. Hold it up against the sun and see if I can see the part number through it. Oh, it's got a baby chicken inside. German design, including circuit integral what are you fucking talking about, man? Salvia? Oh, saliva. Oh, sorry, I read that wrong. Sorry, being a little druggy. No, the saliva's all mine, baby. So we don't have a really good impression of what's doing there. I can try to move it to the schematic land. We found out the identity of 2 of the hidden transistor, or the hidden components. The last one we did happened to be a transconductance amplifier because of the way it was getting power. I recommend for a programmer that's going into electrical engineering world to start with some simulators like Chrome. Back in my day, simulators were like a practical joke against electrical engineers. None of the simulators did anything right at all. They were just a way to get you very, very frustrated at a computer. Unfortunately, that was the state of things then. Now, I think there's better simulation. I'm not the person to recommend, so hopefully there's a good recommendation out there. Some people have done some simulator stuff, and if you don't get a good answer, stream is not necessarily the best place to ask. My Discord, however, is. So if you'd like access to my Discord, here's Discord. And you can pop in there. Maybe somebody will come along eventually, because the Discord gets kind of quiet sometimes. And if a question's asked, you're not going to get an immediate answer, but somebody might float by the answer at some point. And it gives us a little bit less of an immediate thing where you don't have people who are listening to this not getting exposed to the question. There's a lot of these guys in there, these little barrier things. Oh no, those are capacitors. Okay. So how now, brown cow? Cutoff, resonance, envelope, accent, waveform and tuning, selection. That goes all the way over to here. These are wonderful schematics. I absolutely adore that they give you the notes on it and everything too. Dev kits for cheap nowadays like Arduino. Yeah, that's a good place to just put some hardware in your hands, like an Arduino, and get to the point where you're actually running logic code into something instead of worrying about things like flags and registers and clock speeds. So the people may point their nose up at Arduino. You're coming from like programming, and so people like to have fun and jab about various random things like, oh, you did this in Arduino, you dumb fuck, like stuff like that. I haven't run into that personally, but I do see that a lot on things like Hackaday and like AVR dudes and stuff like that. They used to be like that, very, very insular and gatekeepy about how much skill it took to get into programming things that would then interact with meat space in the real world. And to be honest, that's the worst attitude you could possibly ever have, because I've seen a lot of people who are not electrical engineers moving into this space, and I love it because you get people like artists, people who have a sense of design and artistry behind the cool stuff that we can do with LEDs and things. So if you need to flash an LED, you can use an Arduino, who cares? Oh, but you should have a 555 timer. No, you got to do equations for that. Nobody uses 555s. The Arduino is a wonderful jumping point. Everybody has already done every project ever conceived. So you could look up a project that's very oddly similar to what you want to do and find all the code you want. And if you're just coming in from a standpoint of, I want to do stuff with code, well, that's fine. Get an Arduino kit, plug an LED in, and do a hello world. And then you've suddenly got this jumping off point into much more insane and complex things. And in fact, if you even want to go deeper and deeper into the Arduino, there are things you can do within it in order to access the registers and do even deeper stuff. So yeah, I mean, simulation is great though. I'm sure there's lots of places you can simulate circuits. I don't know any of them. I bought an Arduino kit. So yeah, the sky's the limit in terms of projects, but if you want to do free simple simulation, I don't know anything. That would be down to the people in chat that might know about that kind of stuff. I tried VHDL, and it's mind-opening for code guys. Oh yeah. Is that Verilog? Is that FPGA stuff? I think so. I have not messed with FPGAs, and I've been meaning to get into them. I have like a miniature FPGA here, and I could do some cool stuff with it. I don't know what I would do. Does Autodesk do simulation? I didn't know that. Look, Mom, no computer on YouTube. You guys are sending him in all these weird directions. He's looking for simulation, not to actually do stuff in the real world. $100 6502 computer kit. You guys are getting all into the weeds. All this person wants is to be able to click on a screen a little bit and have an electronical circuit with numbers outputting from it, right? What? Show him. Show him. 11220. Hey, thank you for the sub. Breadboard sim is in Tinkercad. Ah, there you go. You might want to check out Tinkercad. Yeah, I would love to be more of a resource for people starting out in the hobby. I started out in the hobby in the early 90s, so I don't know any of the stuff that's out there to learn from these days. My teeth are cut. They're too sharp. Okay, I don't see any very large blocks that this thing is interacting with, this filter here. I know some way, shape, or form there's going to be audio passing through this thing. This thing is laid out in possibly the most confusing way that it possibly could be, with signals going in every direction, because this is a service manual and it's not a functional schematic for working through the circuit and communicating exactly how it's functioning. This is a schematic for communicating the blocks of functionality, what's going in and out, but getting it all exactly right to the point where it's very difficult to monitor what signals go where. You have to come out like, okay, here's the headphone, it goes over here, goes into this amplifier, oops, then it comes out here, and it goes into the volume in and mix in, and there's a dotted line where it comes up to this switch. There's the power switch. Yeah, this is tough to follow. Madam Yu says, main lesson for programming on our Arduino, bit bashing is evil, and if you're having problems, cast your variable to whatever size you're working with, like uint32. So I'm old school, and a lot of the stuff that I do with the microcontrollers is like, if we are doing bit bashing, then I'm going to want to print out the ones and zeros so that I can see what because sometimes they'll do surprising things with bitmath. And so just printing it out to the serial port has been my solution for that. It's like, I want to see what it's doing. Crumb, €5 on Steam. Huh. What are we going into next? Could that be the mixer? I don't think it's going into the mixer. C53, Q33. What is Q30? That's this. That's some kind of a ground. C13 going into the resonance control, coming back over into some of these structures here. It would seem like in order to build this, given 6 transistors that are matched pairs, are those actually matched pairs? From the BC847? Go back up to the top to the description. This is this tiny little part here. General purpose transistor pair in a very small SOT surface mount device package. PNP, PNP complement. Low collector capacitance, low emitter voltage, closely matched current gain. Okay, so these are close matched. They're not super matched, they're closely matched. And that's why they're circled. Okay, so they're closely matched pairs, and so we've got 3 pair there with the bear and his hair. 1, 2, 3, 4, 5, 6, super matched. This would be 5 more transistors, 2 of them wired kind of together. 6, 11, 12, 13, 14. I don't think this is associated with that. Bees! So many bees! Oh, they're gone now. You guys missed the bees. The bees were here, but yeah, they're flying away. They're out. They came in through the window, and now they're gone. How many transistors do we have in the 303? God, that was loud. Okay, let's see here. This is so many transistors. 1, 2, 3. I'm only going to do like the immediate ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21. Oh my God, it's like real stinky down here. That guy needs to adjust his carburetor. Do you think there's 21 of these things down here? That is a lot of transistors. It's definitely a block of functionality here with, well, this is the other so perhaps this and this and this make up that filter, the whole filter block. That would hold a little bit of water, wouldn't it? But I don't know if that's where that's a filter. So that's just a filter. Where are the waves coming from? Voltage-controlled amplifier, voltage-controlled filter. The voltage-controlled amplifier is, of course, the transconductance amplifier that we have. And then the voltage-controlled oscillators over here, that is one matched pair, 4714. What is a 4714? 4714 data shard. Diode semiconductor. Come on. That's not even close. 47114, what was it? I have too many pages open. We have too many parts. Too many parts. I'm going to put the schematic all the way at the beginning of this. Let's go all the way back here. $15 pin? Wait, that doesn't make sense. Wait, 15, you can't have 15 pins. It'd be a 16 pin IC. 4714. Well, we don't know, it could be a dip too. What is that symbol? Where's it all coming from? Signals 1 through 9? Coming off of the main controller. So is this a DAC? No, I don't like to use ChatGPT at all. I don't use it at all. I don't trust it. AI will just lie to you. Plus, what would I even be searching? You can see how quickly I'm answering my own questions. And the reason that it seems like I have a lot of questions is because I'm talking you guys through my thought process as I do this. This is something unique to streaming. It would be something that I would do streaming, and maybe if I'm like teaching somebody else on like a one-to-one level, is I am simply expressing everything that I'm thinking and going through as I do this. You can see how distracted I get and how many tangents I go on, but you can also see the breakdown of the thought process and how I'm logically going through things step by step. There were a couple people that I've gotten praise from for doing, I was doing a lot of, well, okay, the mill broke one day, and so we went through and we troubleshoot the process by going through it piece by piece and narrowing it down to a bad contact. And I actually got somebody watched that and they were like, "This is fucking brilliant!" Like, and they tweeted about it or something to a much larger audience. Actually, it's nice. But yeah, that's what I kind of try to make you guys privy to, is being in the passenger seat as I'm going through all of the ups and downs of reverse engineering something. Sometimes rubber ducks, sometimes I have a pretty good plan of what I'm doing, sometimes you're just there to commiserate. So right now what we're trying to do is we're trying to figure out what this IC is, not this one. Oh, I found it. what this IC is, we do not know. We have another oh wait, that's a lot more than 7 pins. I think that one's the amplifier. Where's the other? This one up here was previously scratched out, and we figured out what this one was by visually. Oh, I still need to figure out where these are connected. We need to figure this one out by, or sorry, we figured this one out. It's all the hydrocarbons getting to my brain. We figured what this thing was by looking at the markings and using a little bit of Photoshop, or in my case, GIMP. We flogged the GIMP until it told us what we wanted to hear. And we were able to figure out what this part was. So I ordered more and I replaced it. And it's still broken, because this thing is still heating up in a weird way. It's a 5 transistor super matched thing, and that is 14 pins. So then we come all the way over here to a completely different part of the circuit where we have this sort of obvious capacitor chain. And the capacitor chain has these little tiny SOT363 parts associated with it. And we know SOT363, they can be voltage regulators, they can be transistors, they can sometimes even be op amps. There's not quite enough pins, maybe a singular op amp. But what we do see, in addition to this, is 3 pins in a triangle. And 3 pins in a triangle is a typical way of putting the pads down for, what is that thing called again? It's a transistor. I gotta look this up. I don't remember. SOT23? I think SOT23. All the packages have these sort of alphanumeric. No, SOT23 is the transistor. Don't look up GIMP package, though. Do yourself that favor. Don't make the mistakes I did. The typical transistor package from the 90s and earlier is the TO92. The TO92 is the typical D-shaped, confusing through-hole package. But we have these weird little guys, and we were able to figure out what the package was. The TO92s use those triangularly located vias for through-hole soldering. So it seems like, and those are unpopulated and unsoldered, so it seems like what they did is they had 2 designs in mind. If this didn't work out, or if this is cheaper, or if this is cheaper, they could swap between the 2. They have a dual matched pair, or you could probably go get some transistors and measure them and match your own pair. But then what's going on with that? Well, this is connected together, which is a very strange way of doing it. But if you look up, and because we worked on this from a fellow who does YouTube by the name of Hajiwo, Japanese, I think, dude who makes modular synthesizer modules super cheap, he did a filter that sounded really nice. And I was like, I want to build that. And it was a diode ladder. And I was like, cool, a diode ladder. Well, that leaded me to the alternative transistor ladder filter. And if you look at that, you can see that it is pairs of transistors with capacitors in between them. That brings us to the TB303 schematic. The schematic for the TB303, the parent of this modular synthesizer module, has such a device. And it uses 1, 2, 3 matched transistor pairs. Hooked up to that matched transistor pair is our mystery chip. And our mystery chip is connected in various different ways. My question, and what I'm sort of theorizing and getting towards, yeah, the TO92 datasheet is one of the most torturous fucking things. It's part of my disdain for through-hole electronics, is that when you look up the datasheet and you look at a TO92 and you're looking up one that's a little bit weird, you don't know if the picture is from the top or the bottom. Am I looking through the package, or am I looking from the bottom of the package? And you can see evidence of this being really annoying in that most data sheets for the TO92s show it in 3 dimensions. And they show you the package in 3 dimensions with the pins sticking out, and then they label the pins. It's just so frustrating sometimes with this stuff. But spatial acuity, surface mount at least, limits some of that need for kind of, you know, can you see the apple in your brain? Do you know what color the apple is in your brain? If you don't see it, then you're going to have a lot of trouble with through-hole. I can see the apple perfectly well. I know what texture it is, but I have a lot of trouble with it too. Just when you flip the board and all your pins are mirrored and stuff. Yeah, sometimes they're like, well, our data sheets are for professionals, and so they don't give you a lot of this extra information. Man, to have one of these things, that'd be so cool. Start making acid house. Yeah. So we know we're here. We just don't know how much of here is represented in the circuit board. And are we actually here? Or are we somewhere else? The oscillation is achieved by this right here. We've seen it many times where they have the base floating and then noise gets into this thing and it does, I don't know, some kind of weird magic in order to create a wave at the end of it. And here they show that they get kind of like a triangle wave out of the thing in the end. TM4 tune, TM5 width, tune, 1110 hertz, C tuning, CD out. This is an awesome resource, by the way. This is just directly from Roland. They have these Roland has these service manuals for all of their electronics, and they're really good. I mean, having these waveforms in here in order to help you work with it, just brilliant. I love it. It's super amazing. Of course, we don't have working hardware that we can work through on a level that this thing describes it. We will have a better idea of that when I start rearranging the circuit and getting to know the things a little bit closer than that. I was hoping that we could make an assumption about what that component is, whether it's, you know, it might be more transistors. It seems like the Roland design is very positive. It's very transistor positive. They're using a lot of transistors in order to achieve their goals. And I have a feeling this is where Acid Labs started off. So there's the power supply. We don't need to worry about that. The voltage-controlled oscillator should be sort of the darling of the entire thing. We have the voltage-controlled amplifier, which for some reason has these things hanging out over here. But I see an amplifier right there. Decay, huh? And then we have the voltage-controlled filter, because this is a voltage-controlled oscillator and filter. And we know that the amplifier section is in there too. This is where we're going to live when we begin piecing together what the schematic is. We're going to be between here, here, and here. These three. Because I have a feeling they took these three circuit elements and they simplified it. 10K, 10K, 100K matched pair. Frequency controlled over there of the filter, I guess. There's a 470K and a 220. Yeah, I don't know. My only problem with it is that this chip is very well isolated from its buddies. Let's back out a little bit because we're not sweating the small stuff with the traces anymore. I'm gonna spend some time with MS Paint this weekend and see if I can't get a functional schematic of this whole thing. There's a lot of components here. It's nothing that I can't handle though. I'm gonna try to figure this out and see if I can't get a good schematic going for this entire thing. Looks like that was supposed to be one of these transistors that's connected in a weird filtery kind of way too. But I mean, you know, I'm gonna start with the power supply so that we know where our powers and grounds are, right? And we know the power supply is over here. Oh, and I'll have to probably do a little bit of reverse engineering for the control panel too in order to figure out what's connected where. I'll maybe start a new layer and do that, which is in fact what we should probably do right now. But so this is the voltage regulator, and so this will be creating some kind of an internal voltage that everybody else is using. Likely 5 volts, but we'll see. Our filter's right there, and then we have our transconductance amplifier. We have our mystery chip, and then way over here we have the chip that's very similar to the mystery chip, which makes me believe that maybe we're not exactly the same. And then over here there's the Schottky, or whatever it is, the Schmidt trigger. Do we see anything Schmidt trigger related in any of this functionality over here? I'm not really seeing it, although we do know that there is a Schmidt trigger in this design somewhere. Is that what this is? Those would have a little symbol in them if they were Schmidt triggers. Because this looks like a resistor ladder, and a resistor ladder you can activate with pins of a microcontroller in order to create different voltages. And that's sort of the basis of a digital to analog. I actually had to do that in a lab. One of my electronics labs, we took a RAM chip, a counter, and some other bullshit, and we put that all together to make a voice recorder. And so we had to make a resistor ladder in order to create the output wave and everything. It was a wire wrapping project, and it was torture. And then I had to do it again in an afternoon for one of my design team members so that they could write a report. I was like, you write the report, I will get you an A in this lab, just go. So I had to sit there and wire wrap until my hands fell off. I never got them back. Where is our Schmidt trigger being used? Looks like around here for interface stuff. Tempo engine. Does this have, what does this have? Accent gate, VCF, VCO, control voltage, slide, tune. There's no sync on this. There's no syncing. But yet one of our chips is a Schmidt trigger. So what are we doing with that Schmidt trigger? Also got the part wrong, but there's a pretty clear part number on it. I know Hedonka was saying that there's you can put a Schmidt trigger into itself and it could create a waveform, but I don't know if that's what they're doing. That seems a little bit far-fetched. I was there, IC6, what was I, whoa. Yeah. Was that all the way up here? Yeah, there's one here. And then there's a bunch of Schmidt triggers over here with the tempo engine. Sorry, there's a delay, so it is very frustrating. I probably have moved on by the time I see your comment. I apologize for that. Yeah, so there's one here, and then the rest of them are over here with, what? I see 6 again. Tempo. Just the way it's receiving an external tempo. And there's a flip-flop there, too. Is this chip a flip-flop? I hope not, because flip-flops break my brain. I don't, flip-flops always mess with me. You can do some genuinely complicated things with flip-flops, and I see them all over circuit design, and they're crazy components, because it's like you have actual memory now. You have a part of your equation that has like memory to it. It's a big deal in electronics. I don't know. I'm gonna have to look some stuff up. I think the best way for me to do this from here out is just to organize it a little bit more. So I'm gonna wrap up. Because it's gonna get real boring when I start to just take what we've got in that GIMP image. I really hate putting it like that, and we're just gonna have to keep. Maybe I'll get a ball gag for the next stream, and that way we can just lean into it fully. But I have this GIMP now, and as long as I can flog it in just the right way, I think we'll all get off. I'm gonna call a pastor or something. Anyway, so yeah, all of this crap that we've done right now is an absolute indecipherable mess. However, well done. If we look at it a lot more closely, if I continue to rearrange these parts, we can come out on the other end with an actual circuit. Now, whether that's done in CAD would make it much easier to keep all of the elements connected to one another, and then you can just kind of rearrange them until it looks good. Or you can do it in like MS Paint, and it'll get painful. And MS Paint is like drawing it in a notebook. You draw it in your notebook, and you arrange things a certain way, and then you take a step back and you look at it and you go, wait a minute, I know this. You look up something on the internet, you figure it out a little bit more, you do it again. Start over from the beginning again. Yeah, MS Paint. MS Paint. Yeah. So that's the process now, right? And I've done this for years. No two circuits will be done the exact same way, because no two circuits are exactly the same, unless you're doing the same thing again, in which case, why are you reverse engineering it? No two circuits are going to be built the same. No two circuits are going to be laid out the same. With the music stuff, I'm thinking, and this is just a supposition on my part, that no silkscreen markings on this thing, which could have saved them a lot by actually putting on the silkscreen how you should plug it into power so it doesn't blow up. But what I'm figuring about this thing is it's a modular synthesizer, right? So it's got elements to it. It has functional blocks that I would assume Acid Labs would take and say, okay, we need a voltage controlled amplifier and we need these specs. Okay, boom, here's a circuit block. Let's edit that a little bit and figure out how to make it work. And in the same vein, I figure hopefully I can take functional elements of this design in blocks and root them out. And what I can do is on this drawing, I can mark down the stuff that I've done already. I can start a new blank layer and I can start like highlighting over things that I've already connected until I've got all of the elements in a readable schematic. And if I do this in CAD, it's going to take me a minute to get all the parts in there. So while I may not put the same exact parts in there, because if I do this in CAD, my end goal is probably going to build one for myself, to be honest. And of course make the circuit layout not annoying. Probably use the same size technology for everything because I do already have some of the parts, but maybe I could make it differently. I don't know. We'll see. We'll see where this goes. But my immediate goal is to fix this thing for Dave, and in order to fix this thing for Dave, I need a schematic. And if I get a schematic, I can relate that schematic to the Roland Rick and Morty. No, I mean the Roland, the regular Roland TB303 service manual, and that'll give me a lot of different things that I can test and figure out and look at and suss out and get working. So that'll be pretty cool. All right, that's it. My brain's gonna explode. I started today with a headache again. This is like the third day in a row that I've had a headache. I think part of it is the wound and part of it is just atmospheric pressure has been kind of high around here. But I am going to adjourn. I'm going to give my brain a little bit of a break before I move on to other stuff. Tomorrow I'm not streaming because I'm still uploading. I have 130 something VODs still to get through. So we started at 350. It's been about that many days and I have 150 left. I didn't know that this would be a full year of uploads. It seems like I can't get ahead of it. Yeah, go cuddle with Willow. I'm gonna go pet my doggy because she's actually been attached to me. It's been warmer around here and the shop has stayed cool because we're underground. So she's been hanging out with me a little bit more lately, which is nice. But yeah, I'm gonna go say hi to my puppy. You guys go to wherever you want to go on Twitch. I'm granting you that. Here's the end card that has a link to the Discord. It has a link to my Twitter, if you're into that. I barely tweet anything. I try to tweet every now and then. I think I did an update of a couple Willow pics. I don't remember. But I'll be on Discord more than anything else. So if you want to hang out, that's where we'll be. And then people are doing stuff all over Twitch. Hope your head feels better. Yeah, I think if I just get good sleep. I got woken up last night by an insulin pump, which is always traumatic. It's not like a directly damaging thing, but it's like you wake up and something's going beep at like a constant tone and you can't figure out what it is until you put your hand on your insulin pump and it stops. And then you have to deactivate it with the phone. You got to go all the way downstairs to get insulin, load up a syringe, end the other pump so it stops going beep, and then you inject the thing, put it on your body, click to start it. It clicks a bunch of times. Then it stabs you. You go, ah! And it goes, yeah, you fucking, and it waves a knife at you. And you're like, whoa, 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 whoa. And then you got to go back to sleep. So that may be why I have a headache today. That I'm yelling at the furniture. And I've got 2-stroke fumes in the lab from the window being open and them doing leaf blowing. So there's a couple factors that are leading into me having a headache. I'm going to stop shouting at stuff. I'm going to get out of this hydrocarbon-filled basement, and then I'm going to pet a puppy. And I think all of those things combined. I'm on a new blood pressure medication, by the way, so blood pressure is not a factor. I'm going to go do that stuff and then die. I'll see you guys never again. Have a good one.